Hey everyone, this is Mariam Fatima and I'm doing BTech from Mechanical Engineering and this is my third year. The topic on which we have made our presentation is air handling unit, and along with me the other colleagues, or you can say my other group members, are Mohammed Sakleen Ashraf and Mohammed Yusuf Ansari. So now what exactly is air handling unit? My colleague, that is Mohammed Sakleen Ashraf, would be letting you all, and let's move towards.
Thank you, Mariam. Hello, everyone. My name is Mohammad Saklan Ashraf, and I am the third year mechanical engineering student at Jamia Millia Islamia. Let me explain you that what is AHU. Basically, AHU stands for Air Handling Unit, and it is an equipment that control and circulate air to the building spaces as a part of building HVAC system, that is heating, ventilation, air conditioning system. And AHU usually connected to a ventilation ductwork that distribute air to the building spaces. Now let's talk about the main function of air handling unit. The basic function of air handling unit is to take outside air, recondition it and supply it as fresh air to a building. Let's move on to the next slide. Now what does an air handling unit consist of? So air handling unit consists of air intake, filter, fan, heat exchanger, cooling coil, silencer and plenums. So these are the parts of air handling unit and you can go through it. Definition is written here. Now move on to the next slide. In this picture you can clearly see the different parts of air handling unit. That here is a sequence that how air move inside the air handling. These are the three research papers that I am going to review today. And the first paper is minimizing energy consumption of an air handling unit with a computational intelligence approach. And the author of this paper is Andrew Kaushik, and it published on 1st February 2013. And this paper is simulation based. Now move on to the next slide. Review of paper 1. The title of this paper is Minimizing Energy Consumption of an Air Handling Unit with a Computational Intelligence Approach. Now before going to review this paper, now the question arises is that why we need to minimize energy. So in a time of increasing energy and water demands, engineer will need to pay more attention to design innovative energy efficient system together with a conservation of natural resources in order to minimize their environment impact. So these are the reasons that we need to minimize energy. So So in this paper, Andrew Kaushik along with the other researchers in 2013 who contributed using a very large extent in this research paper, proposed a computational energy approach to minimize energy consumption of an air handling unit. So our data mining approach basically used here in this paper. Now the question is that what is data mining effect and approach? So it is an approach that includes the utilization of refined data analysis tool to find previously unknown valid pattern and relation in a huge data sets like machine learning techniques, mathematical algorithm. These used in data mining approach. So and the computational results show that the energy consumed by the air handling unit is reduced almost 23%. Now move on to the next slide. Model formulation, and here you can see these are the formulas that is used in data mining approach, and with this help of this approach you can minimize the energy consumption in an air handling unit. A typical air handling unit is an HVAC system supply conditioned air to the building zone. So here these are the formulas. Now move on to the next slide. Now conclusion. So let's talk about the conclusion of first research paper. In researchers reported in this paper, the energy consumed by an air handling unit was minimized by combining data mining with optimization, and a multiple layer perceptron assemble algorithm was used to develop predictive model of an energy consumption, the chiller, and the pump and the supply and return fan to minimize the energy consumption while maintaining the temperature and static pressure of the supply air predetermined level. A non-linear constraint optimization model was developed, and the total energy consumption of air handling unit system was reduced almost 23%. and the future research involves optimization criteria is needed to accommodate different supply air requirements. Example, humidity and CO2 concentration. This research paper have more focused on a single zone modeling. So these are the conclusions. Now let's move on to the next slide. Review of paper 2. The title of this paper is Energy and Water Conservation from Air Handling Unit, Condensate in Hot and Humid Climates. So this paper investigate the potential for energy and water sustainability in hot and humid climates by utilizing the condensate captured from large dedicated air handling units for pre-cooling and outdoor air in another AHUs and subsequently offsetting cooling tower water needs. So in this study, condensate is collected from several HUs and direct through another coil that pre-cools the warm and humid outdoor air, which is supply another AHU called condensate assisted pre-cooling, that is CAP AHU. And it is found that condensate production is large enough to make pre-cooling cost beneficial with energy savings of approximately 10%. That is 10% energy we can save through this process, and ability of offset tower demanded exceed 50%. So these are the benefits of these research paper. Now move on to the next slide. In this picture you can clearly see the different arrangement of air handling units and how it connected with the cooling tower. And this is the condensate energy recovery system using 6 air handling unit with cooling tower water recovery, and these arrangement used to minimize the energy. Now conclusion of second research paper. The second research paper analyzed and performed showed that the production of condensate from 6 large DOAHUs is sufficient to effectively used for energy recovery process with 9.3% savings in case of without heat pipe and 10.9% savings using heat pipe strategy. So these are the conclusions of second research paper. Now let's move on to the next slide. Now review of paper 3. The title of this paper is Reducing University Air Handling Unit Uses Through Control-Based Energy Efficiency Measures. So this paper provides result from University of Dayton case study and the 12 total air handling units in 5 diverse buildings, that is academics, athletics, administrative, place of workshop and library. These are the 5 buildings that selected for the fitting of 6 AHUs. And that were analyzed for energy savings through 3 energy efficiency measures: reducing AHU static pressure, scheduling AHU overnight, and identify and fixing economizer control. So now move on to the next slide. Conclusion of this third research paper, that after analyzing all the 3 different AHUs air handling unit at different places, this paper the author conclude that all the 12 AHUs analyzed in this study were found to have significant energy savings potential through at least one of the following EEMS, that is reducing AHU SP, scheduling AHU fans off nights, and identify and fixing economizer control. And there is a potential of exploring the additional energy savings from dynamic SP resets based on real-time VAV damper position. So these are the conclusion, and I discussed all the 3 research paper. Now move on to the next slide. Here are the references of the all the 3 research paper. You can go through with this reference for any further details.
Okay, so I don't think I need to reintroduce myself. I think all of you are pretty much aware of me. So these are the research papers that I had reviewed. You can see on the screen. So let's move on with the first research paper. Let's get started. Okay, so moving forward with our first research paper, and topic of this research paper is controller design for a real-time air handling unit. Yongshin, along with the other researchers who had contributed to a very large extent in this research paper, so basically they had proposed a real-time HVAC system which implemented a real-time control of thermal environment for virtual reality. Here they had 2 different air loops. hot and cold air loops, which served as thermal reservoirs, and a mixing box, which is used to mix hot and cold air streams, which are supplied from the air loops. The flow rates of these two air streams are controlled to meet the set temperature and flow rate. Now, the algorithm that they used was cascade control algorithm, and gain scheduling was also applied to it. The conclusion that I had drawn from this research paper was that the test results that they had arrived showed that the controller approaches a set temperature and flow rate within 2 to 3 seconds, thereby satisfying the requirements of implementing real-time thermal environment. The software that they used was MATLAB and simulation. So that was it. Next, moving on to the next paper. So these are the formulas that they had used. Okay, so the next paper I had reviewed was adaptive fuzzy multivariable controller designs based on genetic algorithm for an air handling unit. Here, the most important factor that was required for HVAC is like thermal management, effective thermal management, because both energy and operation cost are directly influenced by how good air conditioning works. Now, through the studies, we had examined that a HVAC is typically a non-linear time varying with disturbances, and so where we had used conventional PID controllers, which may exchange between stability and rise time. This was the major drawback, and to overcome this limitation, the researchers had used genetic algorithm-based AFLC, adaptive physiologic controller. Now, the most important factor that they were taking under consideration was that they were continuously modulating the glow valves with equal percentage for chill water and steam. Now, while according to the exact flow rates of water and steam, the conclusion that I had drawn from their research paper was that they had first of all redesigned the whole FLC in MATLAB and Simulink, and the procedure was also proposed by them only. Now their FLC was way better than the existing FLC in terms of steady state error, rise time, and settling time. The software that they used was MATLAB and Simulink. Okay, so these are the formulas that they had used. Okay, so the last paper that I had reviewed was the air handling efficiency and design practices. In this research paper, we had seen that with the help of good practices and life cycle of cost optimization, the SFPI for the fans would be in between 0.5 to 1. But after auditing 987 fans in Sweden, we had come to a conclusion that it was around 1.5. Now, in order to check or search for the explanation for such low performance of the installed system, the researchers had done all the calculations and experiments. After analyzing the contract forms and the consultants' design practices, the two major barriers had been identified, which are listed below. You can go through them. Okay. So this is the conclusion of my reviewed paper. You can go through this conclusion. So these were the references that for the research papers that I had reviewed. So you can go through all these references and you will have those research papers and you can get an in-depth knowledge on these research papers. So yeah, that was it. Thank you so much.
Hello everyone, this is Mohammed Yusuf Ansari. I have reviewed on these three papers which you can see on this current slide. You can pause it and go through the details of these papers. The first paper which I reviewed was a review of fault detection and diagnosis methodologies on air handling unit. Denchai reviewed the faults occurring of heating, ventilating, air conditioning, and refrigeration systems equipments due to improper operations and poor preventive maintenance, which results in excessive energy consumptions, as we all can know. This paper aimed to provide a proper review of existing fault detection and diagnosis, which is abbreviated as FDD, for an AHU and provided new approaches with high performance. Background FDD framework and typical faults in AHUs are presented. A new categorization method is proposed to better interpret the approaches. The conclusion of this paper was that the review described the hybrid analytical approaches and provided the use of evaluation standard parameters for improving the performance of FDD on AHUs. Now, moving to the review of the second paper. Methods for improving efficiency of air handling unit using factor analysis of data. Obi Osintsev worked on the ways of increasing industrial air conditioners efficiency. The current problem of increasing the energy efficiency of the supply and installation is considered in his article. Comparative analysis of the energy saving installation with and without a recuperator for the assembly hall was carried out. Ways to improve the existing equipment are considered. The possibilities of using factor analysis in determining the location of the installation and selecting the number and type of air conditioners were worked upon. Conclusion. The review deals with coolant properties and states that they are different depending on the required room temperature and the type of production. Moving to the review of third paper. Fault detection and diagnosis for air handling on multi-scale convolutional neural network. Fang Yong Cheng, along with his team, in this paper proposed a novel fault detection and diagnosis method using multi-scale convolutional neural network (MCNNs) for air handling unit in HVAC system. Three different scale kernels to improve the ability of feature extraction, and the end-to-end learning strategy is adopted to optimize the model of MCNNs. The proposed method is compared with other 5 commonly used methods using the measured data from an AHU experiment platform. Conclusion. The proposed model eliminates the drawbacks of complicated feature engineering requirements. The review demonstrates that the proposed MCNNs-based FDD method outperform other FDD methods. These are the references of the paper I have reviewed upon. You can go on Google Scholar or Sci-Hub and check the references. Thank you, everyone. Thank you.
For any query related to all the 9 papers that we discussed, you can contact us on our mail account that is written here, and my LinkedIn account also here. You can message me on it. So that's all from our side. Thanks for your attention. Thank you.
Good morning, everyone. My name is Moin Khan.
My name is Maisir Mahmood.
And my name is Muhammad Abid.
And today we, the students of Group 2, belonging to Department of Mechanical Engineering, Faculty of Engineering and Technology, Jamia Millia Islamia, are going to present on the topic of Kalina cycle applications and refrigerants. Moving on to the next slide. We have the introduction to the Kalina cycle. So Kalina cycle uses a solution of 2 fluids with different boiling points for a working fluid. Since the solution boils over a range of temperatures as in distillation, more of the heat can be extracted from the source than with a pure working fluid. Moving on to the next slide. The first paper that I reviewed is thermodynamic analysis of a combined power refrigeration cycle, combination of Kalina cycle and ejector refrigeration cycle. The author of this paper is Chandinis Sechkin, and the research paper type is simulation based and the software uses MATLAB. In this paper, a new power and refrigeration cycle is investigated, which is a combination of a Kalina cycle and an ejector refrigeration cycle. Moving on to the next slide. The results that were obtained from this was that the mathematical model and numerical simulation program was developed, and a parametric analysis was performed for the combined cycle of Kalina cycle and ERC. In the analysis, the effect of variation in combined cycle parameters were considered. And this is the flow chart of the logic that has been used in the MATLAB. Moving on to the next slide. The next paper that I reviewed is the effect of operational parameters on a novel combined cycle of ejector refrigeration cycle and Kalina cycle. The author of this paper is C. Sechkin, and the research paper type is theoretical. The supplied heat to the combined cycle is produced by combustion of biomethane, which is obtained from anaerobic digestion of biomass, which is also called the food waste. And the system reactions to altering operating conditions were considered. Moving on to the next slide. The result of the paper was that the performed thermodynamic analysis for the considered combined cycle were presented, and in the analysis, the effects of variation in ERC, evaporator pressure, condenser pressure in the ERC, superheating degree in the heat exchanger of ERC, and entrainment ratio on refrigeration capacity and power production capacity were considered. Moving on to the next slide. Third paper that I reviewed is multi-objective optimization of an innovative power cooling integrated system based on gas turbine cycle with compressor inlet air pre-cooling Kalina cycle injector refrigeration cycle. The author of this paper is Yang Du, and the research paper type is simulation based. The software that has been used is MATLAB. This paper proposes a novel power cooling integrated system based on gas turbine Kalina cycle system ejector refrigeration cycle in which a high temperature KCS12 is used to recover GT waste heat directly. Moving on to the next slide. The result that was obtained was that the thermodynamic simulation input model parameters are introduced in the thermodynamic model of GT KCS ERC integrated system to conduct simulation process. And this is the flowchart for the MATLAB logic that has been used. This was all from my side. Now I would like to hand over the presentation to myself.
Thanks, Moin. Continue the review. Here is the first paper, Thermodynamic Analysis on a Modified Kalinga Cycle with Parallel Cogeneration of Power and Refrigeration. It's a theoretical paper, and here the cycle cogenerates refrigeration by further reclaiming heat resource from the boiler. A parallel branch of work solution is split at the outlet of the mid-P absorber, and it undergoes pumping, generation, rectification, and condensation before evaporation for refrigeration. Going to the next slide, here the conclusion of the research paper is that the proposed cogeneration cycle, PPR-KC, is based on the triple pressure Kalinga cycle, and the refrigeration branch is parallel to power generation loop, starting from the outlet of the mid-P absorber and ended at the inlet of the low-P absorber. Now, the next research paper is simulation studies on gas-based Kalinga cycle for both power and cooling applications. And the author of the research paper is C.P. Jawahar. And the review, it's basically a simulation-based research paper, and the review is as follows. A detailed parametric analysis is carried out on both simple and gas-based combined power and cooling cycle. The effect of various parameters such as heat source temperature, refrigeration temperature, sink temperature, split ratio, split factor, flow ratio between absorber and gas heat exchanger on the performance of the cycle is studied. The conclusion is as follows. The thermodynamic analysis of the gas-based absorption power and cooling cycle has been carried out for different generator, sink, evaporator temperatures, and split ratio. The split ratio has been optimized, and the optimum value was found. The third research paper is the life cycle assessment of a novel geothermal-based multi-generation system using LNG cold energy, integration of Kalinga cycle, Stirling engine desalination unit, and magnetic refrigeration system. Here the author is Hojat Ansari Nasab, and the research is basically a theoretical research paper. The paper conducts an investigation on a novel multi-generation system developed for MINABST as a case study in terms of thermodynamic, economic, and environmental aspects. The system utilizes geothermal energy source to simultaneously generate 4 useful commodities. Coming to the next slide, the conclusion is as follows. The total energy, efficiency, and rate of energy destruction of multi-generation system are calculated to be 42.95% and 11,382 kilowatt. That's it from me. Now the review is going to continue by Adil Umar.
Thank you, Mahsin. On continuation with the PPT, I'm going to review 4 papers. First one is the coupled cycle with Kalinga cycle systems and vapor absorption refrigerations. The author is R. Shankaran and T. Srinivas. The research paper is simulation based, which is done on MATLAB. Here the systematic flow diagram of the Kalinga and vapor absorption refrigeration cycles. The coupling of the Kalinga cycle system and the vapor absorption refrigerations avoid the repetitive use of common equipments and therefore results in a compact size compared to conventional integrations. Next. Here the thermodynamic analysis using MATLAB. Here the flow charts which we get after analysis done on the MATLAB. And here the results and a discussion and the conclusion. We conclude that the energy utilization factor of the system, which comes to 0.23 to 0.10 respectively. Next. The next one is the thermodynamics analysis on a Kalinga cycle-based power and chilling refrigeration cogeneration cycles. Author is Shahabo, Zhang, and others. The research paper type is theoretical. Here the systematic diagram of the new cogeneration cycle. And basically we studied here 2 types of the Kalinga cycle. The double pressure and the triple pressure Kalinga cycle. Next, if we modify the triple pressure Kalinga cycle, it gets converted into APC. And here we get the result and the conclusions. We conclude that the thermal efficiency of the both power generation and the refrigerations are 30.83% and 50.57% respectively. Next. The third one is the off-design performance analysis of a power cooling cogeneration systems combining a Kalinga cycle with an ejector refrigeration cycle. The author is Young Do and Yiping Dai. The research paper type is simulation based, which is done on MATLAB. This paper conducts the off-design performance analysis of a novel power cooling cogeneration systems combining a Kalinga cycles and an ejector refrigeration cycles for low-grade hot water. Next, here are some parts of the power cooling cogeneration systems are the plate heat exchangers, axial turbines, pump, ejectors, separators, etc. Next. Here the flow charts of the simulation of the power cooling cogeneration system. Next, here the simulations of the power cooling cogeneration systems, the cooling output, total energy output, and net power. And we conclude that the efficiency of the system's thermal efficiency goes from 8.38% to 8.99%, while the exergic efficiency goes up to 39.82%. Next. The last one is the exergy study of the Kalina cycle. Author is R.A. Bajura and others, and the research paper type is theoretical. Here is simplified Kalina cycle diagram, and this paper is basically based on the energy utilization diagrams, and from where we get exergic efficiency of the energy conversion system. Next, utilization diagrams of the Kalina cycle. The diagram shows the schemes of energy transformation by plotting the amount of energy transformation on the abscissa and the energy levels of the donor process and the acceptor process on the ordinates. And we finally conclude that the characteristics of the energy transformation in the Kalina cycle has been clarified through the use of energy utilization diagrams, which shows that the Kalina cycle is very well optimized. Thank you. That's all about from our sides. Thank you.
Good morning, everyone. Today, we, the students of Mechanical Engineering 6th semester, are going to present on the topic Design of Air Washers under the supervision of Professor Karim Isur. Now, these are the contents and the various research papers on which we are going to present our reviews. And at the end, conclusion and the future scope. Now, what is an air washer? As you can see in the figure, the schematic diagram representation of an air washer. It involves the flow of air through a spray of water. During this course of flow of air, the air may be cooled, heated, or can be humidified, or can be dehumidified, or can be adiabatically saturated. As you can see from the figure, there is a pump and an external heater. Now, what the pump is doing, it is recirculating the air. Also, in case of dehumidification, water can also be lost. So, a makeup water is also added. So, in case of dehumidification, if there is any loss, then it can be taken care of. Eliminator plates are provided to minimize the loss of water droplets. Now, moving on with the review of the paper 1. Now, this paper was published by J.C. Santos, J.M. Adrios, J.C. Dos Santos on 3rd July of 2010. Its heading is Analytical Solution for the Simultaneous Heat and Mass Transfer in Air Washers. It's an analytical type. An analytical solution approach for the simultaneous heat and mass transfer problem in air washers operating as evaporative coolers was presented. The equation that described the heat and the mass transfer process in air washers were presented, and an analytical procedure was used for this solution. In order to simplify the solution procedure, a linear approach for the air saturation curve was proposed. Also, a one-dimensional model using the coupled mass energy balance equation for air washer was presented. Now, moving on to the paper 2. Its heading is A Computer-Aided Design for an Air Washer and a Dehumidifier Tested Against Two Graphical Solutions for Its Applications. It was published by Dr. Samir Majlis in 2017. In this research paper, there was an experiment conducted by the above two scientists. There was a MATLAB code which was developed to simulate design criteria used for designing an air washer that was operated as a humidifier for air as well as a dehumidifier. In the first case, a parallel flow of air washer was used to heat and humidify the outgoing air, whereas in the second one, a counter flow spray dehumidifier of the air is accomplished where the air is cooled and dehumidified from its initial condition. The final air temperature was with the help of MATLAB code was 0.06 and the enthalpy of 28.3 lbf. Now moving on to the paper 3. Characteristics of parallel and counter flow of air washer. It was published by Mohammad Ibrahim Alua in 2011. In this experiment, the objective was to present research to study experimentally and characteristics of the air washer having parallel and counter water spraying modes. The investigated cases are different according to the direction of sprayed water relative to the airflow through the water washer chamber. The washer effectiveness and the number of transfer unit mass and heat transfer coefficients according to the wetting ratio were obtained. The study shows that the counter flow mode gave higher characteristics than the parallel flow. The result encompasses the washer effectiveness eta, the number of transfer per unit, and the transfer coefficient of mass in it. Now, I would like my friend Anirudh Tiwari to move on with the next papers.
reviews on the very same topic. At very first, we reviewed the research paper of I.M. Ismail and K.G. Mahmood in comparative study of different air conditioning systems, which incorporate air washers. As mentioned in the highlights, it was proposed by Walker in 1923. He proposed this by combining the heat and mass transfer equations and used enthalpy as the driving forces allowed heat transfer. It brings them in close direct contact. Heat is transferred to the water droplets into air present in the cooling tower. The air washer is integrated with air conditioner cooling system. The basic use of air washer is to cool the air by bringing into direct contact with the water droplets. The basic structure of cooling tower is shown here. As we can see, the heat is being transferred through the air from water droplets in cooling tower. Vibhor, can you please present next slide? Next slide, please. Yeah, thanks, Vibhor. Coming to the next review, we reviewed the research paper of Stuart A. Batterman, Harriet Burge on HVAC systems as emission sources affecting indoor quality. Indoor air quality can be studied in various aspects, such as pollutant emission sources, transport, etc. This review had focused on the negative impact of HVAC systems as a source of pollutants or because of contamination. Air washers are very useful in such cases to prevent us from these types of hazardous elements. Now, coming on to the next review, we reviewed the paper of Siddharth Chakrabarty and Prashant Kumar Das of performance investigation of air washer for different psychometric conditions. This paper develops a different approach for the effectiveness of air washers. It also studies some important parameters such as airflow rate, inlet humidity ratio, etc. It was observed that efficacy of air washers increases by reducing inlet water temperature or flow rate and inlet humidity ratio. Coming to the next review, we reviewed the paper of S. Jyotirmalingam D. Mohanlal on performance study of air washer chilled water coil system for a yarn industry. In this, the basic principles including effectiveness, saturation efficiency, and energy consumption for the systems are evaluated. It also prevents from the contaminated products in yarn industry entering into the system. It also prevents the result of direct evaporative cooling process. Now, I would like to call my friend Utkarsh to continue with the further slides.
So, hello everyone. This is Utkarsh, one of the batchmates from 6th semester mechanical engineering. Now I'm going to review this paper 8. So this paper is energy and exergy analysis applied to the evaporative cooling process in air washers, and it was published by GDT Barrows, J.M. Gergel, and F. Balconde. This is a model-based research paper, and various effects on air washers were being studied throughout this paper, including the dry bulb temperature, humidity ratio, water temperature, washer length, etc. And various exergy analysis and mathematical modeling were being conducted to execute and arrive at the results. The proposed model can be utilized in the development of more accurate numerical methods for the simulation and performance evaluation of air conditioning systems, which extensively use air washers. Now let's move to the next review. This paper was published by Mr. Pandey, R.M. Baghel, and Parrott, and it was based on the operational experience of air washer based ventilation system for power. So it was basically used for Indus 2, which is a cyclotron accelerator. And why was it being used? Because evaporative cooling design is being preferred over refrigerated one because of lower initial capital cost, lower energy usage in running costs, and it emits less greenhouse gas. So design philosophy, installation, instrumentation, testing, operation experience, and availability of the ventilation system has been very well explained in this paper. So now let's move to the next paper. This is a type of numerical analysis based paper which was done on the energy reduction of an exhaust air heat recovery, and this was being published by Song, Jansu, and Kyung Ho. It was based upon the energy consumption of outdoor air conditioning systems, which represents about 45% of the total AC load. So what was being done is the design of air washers in this case is a key point to how efficiently heat recovery occurs. So lab scale experiment showed that about 1000 meter cube per hour of air that was proposed system was more energy efficient. So the present numerical results were relatively in good agreement with the available experimental data. So heat recovery from exhaust air was the main focus in this paper. So we have reviewed about 10 papers. Now let us move to the conclusion on the design of air washers. Basically, we can say that there are five main factors upon which the design of air washers depends. First is requirement, the purpose for which the air washer is to be used. Second is of course energy efficiency. If you are using it for bigger application, then efficiency has to be higher. And if it's for a shorter, smaller application or domestic purpose, then it can, vary. The size can also depend upon the industry, and the cost and feature maintenance is also one of the most important factors, which helps in determining the recirculation percentage using AC. And other additional features can obviously depend according to the applications they are used for. So the board move to the next slide for future scopes. So the future scopes of design of air washers is about the idea to overcome the drawbacks of existing air washer used in industry or anywhere. The main problem with this is that it had many problems. So now solar powered air washer, which uses lower pumps, nozzles, heating, and cooling coil and reservoir, are far better than that. It has been also proposed that the work on a conventional solar cell equipped with the self-sustainable humidification and open air flow stream is to be done to enhance the system productivity, which is going to help. So yeah, there are a lot of future scopes in the design of air washers according to the air conditioning industry, and a lot of research is being done. This changes, these changes maintain higher temperature difference between cell and water in the condensing surface. So there is a lot of future scope in the design of air washers. That's it from our side. Now we would like to say thank you, and now we are open for questions as well. You can ask your doubts in the comment section below.
Hello everyone, this is group number 4, consisting of me, Mozam Farooq, Qasim Farooqi, and Saeed Abul Masood. The topic given to us is waste heat used in air conditioning system. These are the contents that we are going to cover in the upcoming presentation. Now starting with the introduction. Waste is produced by a machine or that uses energy as a byproduct of doing work. All such processes give off some waste heat as a fundamental result of the laws of thermodynamics. Waste heat has lower utility than the original energy source. Waste heat found in the exhaust gas of various processes or even from the exhaust stream of a conditioning unit can be used to preheat the incoming gas. This is one of the basic methods of recovering of the waste heat. Many steelmaking plants use this process as an economic method to increase the production of the plant with lower fuel demand. There are many different commercial recovery units for the transferring of energy from hot medium space to the lower one. Now, starting with the literature review of the research paper, these are the topics that I'm going to cover. Starting with the first topic, which is efficient usage of waste heat from the air conditioning, written by M. Joseph Stalin, published in July 2012. This paper concentrates on the theoretical analysis of production of hot water and reduction of LPG gas using air conditioning waste heat. Nowadays, air conditioner is a banal device which occupies most of our condominium for our comforts. An attempt has been taken over to recover waste heat rejected by the 1TR air conditioning system. For this, water-cooled condenser is exerted and the water is promulgated by the pump until a desired temperature is required. Then the hot water is accumulated in insulated tank for our use. The result of the paper shows that the temperature of hot water, time required for attaining that temperature for the necessary volume of the water, and the reduction of LPG gas by using hot water is also confabulated. Factors like supply and demand, condenser coil design are bounded and theoretically calculated. Finally, this could be the surrogate for water heater, and it fulfills all the applications of hot water. Similarly, it could tackle the demands of LPG gas as well. The second topic is waste heat recovery through air conditioning system, written by R.B. Lokapur et al. December 2012. Today, in this paper, the main stress is given on the energy conservation by using techniques of utilizing waste heat from air conditioning system and increasing COP. The target of improving COP was up to 20%, but in this case, we achieved our goal by recovering energy and improving COP up to 13%. The heat recovery system is designed for the available desuperheating heat in the window air conditioning. The available heat is calculated by using the rated conditions of a window air conditioner, and after that, the heat exchanger design is done for the heat recovery. The third topic is waste heat energy utilization in refrigeration and air conditioning, written by Raman Kumar Singh et al. In 2018. This project is one of the reusable and an eco-friendly project which can be implemented in our day-to-day life for the effective management of the power and consumption factor. The heating unit in the system utilizes heat loss through the condenser and thereby saving energy. By the utilization of wastage of heat energy, performance of the system has improved significantly. The system can be utilized throughout the year according to the need, and finally a simple working model of the system is fabricated and tested. Now I would like to call my colleague Sayyid Umar Masood for the next part.
Okay, so here are the topics we're going to cover in this literature review second part. Starting with the first topic, which is waste heat recovery from central AC system for hot water supply. That is a case study for hotel building application in Indonesia. So this paper studied integration of hot heat pump and air conditioning systems to provide heating for hot water as well as cooling for hotel services based on weather conditions and energy costs in Indonesia. Okay, so the study was conducted for a 5-star hotel of 636 rooms, 30 apartments, and 25 meeting rooms. The results showed that optimum arrangement of the integration could reduce 36.7% of energy consumption for space cooling and hot water supply. It was also found out that by utilizing 30-meter cube hot water storage, hot water demand of the hotel can be satisfied from heat recovery system without heat pump. Here comes the flow chart in which the system has been shown about how the process will be undertaken. Coming on to our next review paper, that is a cooling system of an automobile based on vapor absorption refrigeration cycle using waste heat of an engine, which is presented by Satish K. Maurya et al. Presented in March 2014. So the basic objective of developing a vapor absorption refrigerant system for cars is to cool the space inside the car by utilizing waste heat and exhaust gases from engine. So in today's world, we use vapor compression refrigerant system, which is abbreviated as VCRS. So majority of vehicles today use are either spark ignition or compression ignition engines. So the energy input required by the vapor compression cycle is applied to the compressor in the form of mechanical work, but in the absorption cycle, the energy input is mostly in the form of heat supplied to the generator. In the present case, the heat source is the exhaust heat of an internal combustion engine. Coming on to the next paper, we have air conditioning and water heating, an environmental friendly and cost-effective method of waste heat recovery, presented by M.M. Rahman et al. March 2014. So far, 2 types of research activities have been conducted to recover waste heat from split-type air conditioning systems. So the first type of air conditioning, in which the condenser of the air conditioning unit is replaced by the copper tube, which is submerged in a water tank to warm up the water to be used for domestic purposes. In the second type of waste heat recovery device from split air conditioning, the heating tank is designed in a way that the copper tube conveying refrigerant is not submerged in water. The heating tank consists of 2 cylindrical chambers. The inner chamber, which is filled with water, is cooled with a hot refrigerant conveying tube at the outer surface. So the components which are required are shown in the below table. Coming on to the next review paper, which turns out to be improvement of solar septic tank performance by recovering waste heat from an air conditioner unit, presented by T. Posavania et al. 2019. So SST, that stands for solar septic tank, is considered as an effective sanitation technology by inactivating pathogens, converting organic waste into methane biogas, and alleviating the environmental concerns associated with fecal sludge handling. So the system consists of mainly of 4 parts: evaporator, absorber, condenser, and generator to capture waste heat, discharge from the refrigerant cycle of an air conditioner, and transfer the heat energy into a water heater tank. This is a formula by which the generated energy is calculated, and we have some conclusions which direct us to the TCOD, BOD, and TSS. And it also suggests that the treatment forms are SST integrated with WHR unit. The technical feasibility in heating black water to improve environment conditions and public health protection will be increased. Now, handing over to Kasim Faruqi, we will explain the further literature reviews. Thank you so much.
Hello, so I'll be taking over to cover the literature review third part. So I'll be covering these following topics. Next slide. So the first topic is internal combustion engine waste heat potential for an automotive absorption system of air conditioning. Part 1, test on exhaust system of a spark ignition engine. So it's an experimental procedure performed by P. Boato et al. In August of 2000. Measurements have been carried out on a 4-cylinder spark ignition engine to estimate the amount of heat recoverable, in particular when the engine runs at low loads. So there are two possibilities of heat recovery from the exhaust. We'll be focusing on tests on a spark ignition engine for our case. The results concluded that when the engine runs below the threshold value, additional burners might be necessary to ensure that the absorption system produces the required cooling power. And when the available exhaust power exceeds the threshold value, the possibility of storing cooling power to be used is not sufficient. These are the graphs obtained from the experiment. So the next topic is recovery of engine waste heat for reutilization in air conditioning system in an automobile and investigation. So it's an experimental procedure performed by D.G. Mahato et al. In January of 2012. Their major concern has been the rapid change in atmospheric effect, increasing cost of the fuel, etc. They have even suggested the use of VARS in place of VCRS, which have mostly been used in vehicles. So in this research paper, they have proposed a methodology where they have experimented with a triple fluid vapor absorption refrigeration system using ammonia, water, and hydrogen as the fluids in order to generate heat for the absorption system and cooling. The study reveals that it comprises of 4 heat exchangers, namely an air-fin force convection condenser, an air-fin force convection evaporator, and a pair of shell and tube type absorbers, plus 4 one-way refrigerant valves, an expansion valve, and an exchange valve. So the next topic is performance evaluation of a waste heat-driven absorption system for an automotive air conditioning, part 1, modeling and experimental validation performed by M. Verde et al. In September 2016. In this first part, the theoretical and experimental investigations were performed on a 2-bed silica gel adsorption chiller for an automotive application. A prototype adsorption system with a total weight of about 86 kilograms was developed and tested to driven by low-grade waste heat. The single adsorbent bed consisted of 3 plate fin heat exchangers connected in parallel. An improved non-equilibrium lumped parameter model was developed to predict the transient performance of the system. The results show that the model is able to accurately predict the dynamic performance of the system under different operating conditions and configuration modes with a short calculation time. The tested chiller was able to produce an average cooling capacity of about 2.1 kilowatts with a COP of 0.35 at the rated operating conditions. Heat recovery system results in increasing the COP by 43% and cooling power by 4%. Now moving on the future scope. So we believe that our topic can be extended to medical fields as well. Heating and ventilation air conditioning systems in hospitals can be used to govern transmission and spreading of airborne illness along with COVID-19. A few studies suggest that the shortest time of survival of SARS-CoV-2 in aerosol shape is 4 hours, and the virus turns inactive about 60 degrees Celsius in air temperature. Consequently, SARS-CoV-2 droplets can't go out from exhaust duct if the temperature is about 60 degrees Celsius. At the condenser, heat is dissipated in the form of warm air, which might be applied to heat the exhaust air. Hence, we can set up a unique technology for disposing SARS-CoV-2 from clean HVAC systems using the recovered heat of the exhaust stem. So this concludes our presentation. We have learned about the waste heat and how waste heat can be utilized in and from an air conditioning system. These are our references that we have used for our literature review. Thank you.
Hello everyone. I hope everyone is doing good. I am Asif Khan, and I, along with my group members, Samir and Adil, we are going to give a presentation on the topic of ejector refrigeration system. So here is the introduction part of it. Ejector refrigeration system is just a thermally driven technology that has been used for cooling applications for many years. Currently, they have a much lower coefficient of performance than vapor compression system, but offers advantages of simplicity and no moving parts. They also have a low maintenance cost because they operate on ejector instead of a compressor. Their greatest advantage is their capability to produce refrigeration using waste heat or solar energy as a heat source. Now, this is the schematic diagram of ejector refrigeration system, which shows the processes involved in this cycle and the main major component. Now, these are the major components which are present in ejector refrigeration system. The first one is ejector and then the condenser and evaporator, boiler, pump, and expansion device. Now I'm going to review the reports. So the title of the first report is Investigation and Improvement of Ejector Refrigeration System using Computational Fluid Dynamic Technique. The author of this report is K. Piang Thong, and the publication date is September 2007. This is a theoretical analysis. So this theoretical analysis is performed for an efficient design of the ejector just to improve the ejector refrigeration system using CFD technique. So CFD can predict ejector performance very well. It also reveals the effect of operating conditions on an effective area that is directly related to its performance. In a nutshell, the ejector performance related to its flow phenomena can be understood and also become very useful tool to design an appropriate ejector. Now, this is the second report, and the title of this report is Experimental Determination of the Optimum Performance of Ejector Refrigeration System, depending on ejector area ratio evaluation. The author of this report is R. Yapisi, and the date of the publication is November 2008. This is also an experimental analysis type of report. And in this report, the author is using six configurations of ejector and R123 as a working fluid to determine the performance of the system. The study is performed over a range of ejector area ratio from 6.5 to 11.5 at the compression ratio 2.47. In this range, the experimental coefficient of performance of the system rises from 0.29 to 0.41 as the generator temperature increases from 83 degrees Celsius to 103 degrees Celsius. So for a given ejector area ratio, there exists a generator temperature at which the maximum COP is obtained from the ejector refrigeration system. So this now here is the third report, and the topic of the third report is experimental investigation of R134A vapor ejector refrigeration system. The author of this report is A. Selva Raju, and the date of publication of this report is November 2006. This experimental analysis studies about the influence of generator, evaporator, and condenser temperatures on the system performance. The system is using R134A as a working fluid and has a rating cooling capacity of 0.5 kilowatt. This kind of system can be operated with low-grade thermal energy such as solar energy, waste heat, etc. It is observed that for the given condenser and evaporator temperature, every ejector with particular configuration has an optimum generator temperature at which maximum COP can be obtained. The system with ejector having higher area ratio yields a higher critical COP. Now I am going to hand over this presentation to my friend Abdul Adil Hussain to carry on the further discussion. So Adil Hussain.
Yeah, thanks Asif. Now I'll review on the fourth report, which is a performance characteristic of ejector refrigeration system based on the constant area ejector flow model. The author of this report is R. APC, and the date of publication is given here. And it is a theoretical analysis of ejector refrigeration system, which is performed based on the constant area ejector flow model using R123 as the refrigerant. In this, there is analysis of ejector flow models, which are of two types. The first one is the constant pressure ejector model, and the second one is the constant area ejector flow model. In constant pressure model, it is assumed that primary and secondary mix at a constant pressure between sections. Also, velocity is uniform at all sections. In this, flow converts to subsonic due to shock wave reduction. It is found that for the same area ratio, the COP for the system with constant pressure ejector is relatively higher than that of the constant area model. So we'll move to the next one. Change the slide, please. So here it is the next one. The next one is an experimental investigation of a R134A ejector refrigeration system. The author of this report is R. Garcia del Valle, and the date of publication is October 2014. It is an experimental analysis. In this study of the critical condition for three different geometries has been performed. Author has taken three mixing chambers. It has named as A, B, and C. All of them have the same constant area diameter, but different entrance geometry. In this, the initial results have shown that the stagnation degree of superheating for both primary and secondary flows doesn't affect the mass ratio for values higher than 10 degrees Celsius. The purpose of the experimental result is to identify the critical condition for the 3 mixing chamber geometries and for a number of stagnation conditions for both primary and secondary flows. And the next one is, change the slide. Report number 6. It is on the topic of experimental study of the performance characteristic of a steam ejector refrigeration system. The author of this report is Yao Ming Chen, and the date of publication is November 1997. It is an experimental type of analysis. In this experiment, it investigates the controlling parameters of a steam ejector, including operating conditions and the exit Mach number of the primary nozzle. A comparison among refrigerants shows that the performance characteristic of a steam ejector itself are better than those of R114 ejector and R113 ejector. Initial results have shown that the stagnation degree of superheating for both primary and secondary flows doesn't affect the mass ratio for values higher than 10 degree. The observation of the flow field shows that there exist condensed droplets and mist, and a circulating flow is formed in the edge region of the mixing section. Now we'll move on to the next one, which is the 7th report. Here it is a theoretical analysis of ejector refrigeration system performance under overall modes. And the author of this report is V. Sang Chen, and the date of publication is 1st January in 2017. It is also a theoretical analysis. In this, the author has done a theoretical calculation based on the real gas property to estimate the ejector refrigeration system performance under overall modes. The finding shows that the proposed model has higher accuracy compared to the model using the ideal gas law, especially when the ejector operates at subcritical mode. The result also shows that R290 ejector circle has highest COP under critical mode and could operate at low evaporator temperature. In a word, the present model could provide an effective tool to design and analyze the ejector refrigeration system. This study may offer a good reference for the ejector refrigeration system design work. So I have completed all my reports. Now I'll give the chance to Samir to carry out the discussion further. So here's Samir.
Thank you, Adil. And my topic is an exergy analysis of solar-driven ejector refrigeration system. And the author is Vimolsiri Pridavas, and the date of publication is April 2004. And it is a theoretical analysis. The aim of this theoretical analysis is to find optimum operating condition for a solar-driven ejector refrigeration system. Exergy analysis is used as a tool to analyze the performance of a solar ejector refrigeration system. The most significant losses in the system are in the solar collector and ejector. The minimum losses for a specific evaporation temperature can be obtained at optimum generating temperature. However, the optimum generating temperature is about 80 to 100 degrees Celsius, depending on the evaporation temperature. It is found that the high temperature solar collector is not necessary for a solar-driven ejector refrigeration system. Now, the next review on the topic is conventional and advanced exergy analysis of an ejector refrigeration system. And the author is Yang Chen, and the date of publication is 28 January 2015. And it is also a theoretical analysis. In this theoretical analysis, the author has done a comprehensive investigation of an ejector refrigeration system using conventional and advanced exergy analysis. The combination of splitting approaches identifies the order for a system improvement. The ejector should be firstly considered, then the condenser, followed by the generator. The application of advanced exergy analysis to the ejector refrigeration system provides detailed and very useful information and identifies the direction for a system improvement. It can be viewed as a valuable supplement to the conventional exergy analysis. Now, the next review on the topic is experimental investigation on ejector refrigeration system with the ammonia. And the author is T. Sankaralal. The date of publication is July 2007, and it is an experimental analysis. In this experiment, the performance of ejector refrigeration system has been experimentally studied with 3 different area ratio ejectors by varying operational parameters, namely generator, condenser, and evaporator temperature. The result shows that entertainment ratio of coefficient of performance of the system increases with increase in ejector area ratio, expansion ratio, and the increase with decrease in compression ratio. The diameter of nozzle and mixing chamber are different. Performance of the ejector refrigeration system depend on area ratio alone. Now, the conclusions are ejector refrigeration system can be powered by low-grade heat with a contribution of a small quantity of work required to circulate the working fluid. Therefore, they are potentially interested in CCHP application. Ejector refrigeration exhibit low thermodynamic efficiency with COP values usually in the range of 0.1 to 0.7. However, they are relatively simple, inexpensive, both in construction and operation. An ejector refrigeration system can be considered as a modification of conventional vapor compression cycle, VCC. And the future remark for all the reviews are, for ejector refrigeration systems, are ejector chiller may represent a competitor for absorption chillers as soon as their cost per unit cooling powers become equal or lower. This target is not far from our present achievement. If input energy is waste or renewable heat, the system operating cost is mainly due to the investment in heat exchanger. Therefore, a cost reduction requires an increase of COP. This may be improved by a careful design of the ejector, which require a deep insight into the thermodynamics and fluid dynamics of its complex physics. Now we have done our reviews and we thank you.
A very warm welcome to all of you present here. Today, group members of Group 6, comprising of Afreen Ryan, Shazia Sajjad, and myself, Khadija Safia, are going to present to you our presentation on the topic Implementation and Completion of Montreal Protocol in India. For this, we would like to thank our Professor M.N. Karini sir to give us this opportunity to express ourselves before you. Now, moving on to the presentation, let's see what Montreal Protocol is. So it is an international treaty designed to protect the ozone layer by phasing out the production of numerous substances that are responsible for ozone depletion. And it has been termed as single most successful international agreement to date, that has been Montreal Protocol. Now there is a diagram to illustrate how ozone depleting substances cause depletion of ozone layer. So ODS comprising of chlorofluorocarbons and hydrofluorocarbons result in depletion of ozone layer, which is present in the stratosphere. This becomes harmful as it protects us from the harmful ultraviolet rays of the sun. Therefore, depletion of ozone layer becomes very dangerous for human beings. Now we move on to the papers and review them one by one. So first of all is the implementing international environmental treaties in developing countries, China's compliance with the Montreal Protocol. So this paper basically deals with Montreal Protocol multilateral fund that has played a key role in China's compliance. The sector-based approach to funding, which approved sector-level funding and targets for reduction of ozone-depleting substances, has been more effective in changing government and industry behavior. Now moving on to the second paper, Future Atmospheric Abundance and Climate Forcing from Scenarios of Global and Regional Hydrofluorocarbon Emissions. So this paper deals with global adoption of technologies required to meet national regulation would be sufficient to reduce by 2050 baseline HFC consumption by more than 50% of that achieved with the North America proposal for most developed and developing countries. Third paper deals with India Cooling Action Plan. So this paper sorts the following benefits which we can get by India Cooling Action Plan, which are to reduce cooling demand across sectors by 20% to 25% by 2037-38, reduce refrigerant demands by 25% to 30%, training and certification of 1 lakh servicing sector technicians by 2022-23, synergizing with Skill India mission. Now I would like to call upon my friend Afreen Ryan to further continue with this presentation.
Thank you, Khadija. Hello, everyone. My name is Afreen Ryan. Let's move on. Introduction to the special issue on ozone layer protection and climate change. The special issue on the ozone layer protection and climate change reflects the leadership of the Association of Environmental Studies and Science in drawing interdisciplinary attention to important environmental issues. Scientists, government officials, scholars, and business people must push for higher standards to achieve the combined goal of reducing both ozone-depleting substances and greenhouse gases. The Montreal Protocol Act 20. Our approach utilized data from projects funded by Montreal Protocol's multilateral fund and from the emerging carbon emission markets to measure what is currently being spent by government firms and international agencies to reduce emission of the ozone-depleting substance and greenhouse gases. Now we'll move on emission of carbons from India infrared through atmospheric measurement. We use many halocarbons in refrigerant like HFC 32, HFC 143A and provided evidence to suggest that HFC 32 emission were primarily due to fatigue emission during manufacturing process. In India, we use refrigerant blends R410A, R404A and R507H was limited despite extensive consumption elsewhere in the world. The rapid growth of India's economic and the likely increase in demand for halocarbons such as HFC, the implementation of long-term atmospheric monitoring in the region is urgently required. Knowledge management in development project, a case study of the HEDECORE project in India. To ensure replication of the successful development project, it is important to identify and harness both kernel and informal knowledge. This paper critically examines a development project called Human and Institutional Development in Ecological Refrigeration in India. The paper illustrated the issue of the scalability and application of project activities had been addressed and the systems developed for the project were useful in the designing and implementing a follow-up project. Now I will call up my friend Shazia Sajjad.
Thank you, Afrin, for handing me over this presentation. Now myself, Shazia Sajjad, and I'll be continuing with the presentation. Okay, in this first paper that I have reviewed, so this was an experiment that focused on residential air conditioning sector in India and analyzed a suite of HFC and alternative coolant gas scenarios for understanding the implications of greenhouse gases, that is GHG emissions, from this sector within an integrated assessment modeling framework. Okay, next slide. Perfect. So this is the paper that suggests some of the solutions in order to improve efficiency and refrigerant transition in air conditioning. So implementing or reviewing standards and leveling programs to improve efficiency level with the possibility of adding a low GWP, that is global warming potential criterion. In combining fixed speed and inverter AC product categories to account for seasonal variations in climate and part load operation conditions, and using seasonal air and energy efficiency ratio, that is EER, instead of energy efficiency ratio, that is EER, to better reflect performance of inverter AC. So can we have the next slide, please? Perfect. So in this paper, a vision for the future with environmental refrigerant is described. Innovations such as a new type of component, new concept of low charge ammonia system and their expansion in many applications. There are improvement of CO2 system, installing parallel compressor, ejector and an expansion device and usage of evaporative condenser. There is a big potential of R290 to be better refrigerant number 1 for split air conditioning units. Finally, a new approach is recommended. Okay, can we have the next slide, please? So here is the conclusion for our all research papers that include the way forward for better implementation of Montier protocol. That says some of I will illustrate here. That is usage of absolute technology during transition to low GWP refrigerant can be mitigated by updating a standard and reviewing them periodically to ensure their effectiveness. Okay, next slide. Perfect. Here are some of the references that we have added in this presentation. So next slide. Here are some more references that we have added. Okay, with this we would like to end up our presentation and hope you all liked it. Thank you for listening us.
Hello everyone, this is Abu Tariq Zia, a student of BTech Mechanical 3rd year Jamia Millia Islamia, and I welcome you all to presentation by Group 7. In this presentation, I along with my group member Asif Zia and Dilsad Alam are going to review 10 research papers based on application and limitation of thermoelectric refrigeration system. But before we get to review, I am going to share some basic information regarding the thermoelectric refrigeration system, and then we will move to the review. Thermoelectric cooling uses the Peltier effect to create the heat fluxes, which is used for heating or cooling. This technology is far less commonly applied to the refrigeration than vapor compression system due to high cost and lower performance. Next slide. Advantages of thermoelectric cooling. No use of CFC, ability to heat and cool, no moving part and fluids, generate no noise, lightweight, compact, etc. Limitation of thermoelectric cooling, able to dissipate limited amount of heat flux, lower COP than VC system, higher cost, inability to work efficiently in large temperature ranges. Next slide. Major application of thermoelectric coolers, which are used by military, medical, industrial, consumers, laboratory, etc. Applications are water cooler, cool car seat, laser cooling, etc. Next slide. First review, comparison of the optimal performance of single and two-stage thermoelectric refrigeration system. The author discussed the need for two-stage thermoelectric refrigeration due to ineffectiveness of single-stage thermoelectric refrigerator in large temperature ranges. Cycle model of two refrigeration systems are used to derive expression for COP and rate of refrigerations. The single stage thermoelectric refrigerator is more convenient to use when the temperature ratio of the heat sink to the cooled space is small. However, two-stage thermoelectric refrigerator should be used in case of large temperature ratio. Authors claim that the result obtained may provide theoretical basis for optimal design and operation of two-stage thermoelectric refrigeration system. Photovoltaic-driven thermoelectric refrigerator for car heat dissipation during sunny days. Based on experimental work in the automobile industry, the air conditioning system increases the problems such as pollution to environment, increase in usage of fuel, and decrease in engine performance. To overcome this problem, the thermoelectric devices are used. In this paper, two experiments were conducted with and without using the refrigeration system on the model, and the results were compared. Heat load was reduced using the refrigeration method. To run the refrigeration system, solar energy are used, and this system contains no moving part, reliable, and produce no noise. Next slide. Third review. Thermoelectric cooler and thermoelectric generator devices. A review of present and potential application, modeling, and materials based on analytical work. Thermoelectric cooling systems provide heat loss recovery of thermodynamics units for power production of remote areas. Semiconductors, ceramics, and polymers are the most used material in the fabrication of thermoelectrics. Swan defined two novel model to provide a simplified equation for calculation of temperature differences, cooling rate, and COP respectively. Next slide. Bank designed a model for a novel TEC and TEC heat pump was driven by TEG and also performed an optimization to maximize the performance of the systems. Leo performed an optimization on the heat transfer area of two heat exchanger in a TEC system in order to enhance the COP and cooling system, and established the heat transfer model to the heat sink or the heat exchanger devices can strongly affect the performance of the thermoelectric module. It is so that the implanting insert at the channel wall could enhance the output power up to 110%. Next. Now I like to call Asif here to continue the presentation.
Hello, myself Asif here, and I will be continuing the presentation from here. So the very first paper that I reviewed is material for thermoelectric refrigeration. So this paper discusses about the material of thermoelectric refrigeration system, which is Bi2Te3 and their alloys. This paper also discussed briefly about the criteria for determining the optimum properties of material for thermoelectric refrigeration. Next slide. In the conclusion of this paper, we found that the solid solution alloying of Bi2Te3 with Sb2Te3 and Bi2Se3 results in only a small increase in Peltier cooling in spite of a marked decrease in the lattice thermal conductivity on alloying. It was also found that the addition of the third compound on the binary alloy enables one to increase the band gap in such a manner to avoid the above mentioned overlap and thereby to figure of merit. Next slide. Second paper is review of thermoelectric refrigeration and application and technology. Refrigeration means removal of heat from a substance or space in order to bring it to a temperature lower than those of the natural surroundings. Now, thermoelectric refrigeration provides cooling effect by using thermoelectric effect, which is Peltier effect, rather than the more relevant conventional method like those of vapor compression cycle or the gas compression cycle. Thermoelectric refrigeration find application in electronic system and computer to cool sensitive components such as power amplifiers and microprocessors. Next slide. This paper reviews the development in TER system over the years. This study of the thermoelectric refrigeration emphasizes that the TER system is a novel refrigeration system, which is a better alternative for conventional refrigeration system. Next slide. So the third paper that I reviewed is heat rejection alternatives for thermoelectric refrigerators. Refrigerators may be defined as a process of removing heat. This process may be accomplished by using one of the refrigeration systems such as vapor compression, absorption, or thermoelectric refrigeration system. Now, single fan, double fan, and natural chimney draft heat rejection alternatives have been tested in this experiment. the minimum temperature reached is -3 degrees Celsius. The temperature difference between the hot side and the cold side is 26 degrees Celsius for natural cooling, 22 degrees Celsius for single fan, and 14 degrees Celsius for two fan system. Now, it has been concluded in this paper that if you use a long chimney, the performance of refrigerator may be improved, and the fan current is used for cooling instead of wasting its power for heat rejection fans. Next slide. So the last paper that I reviewed is use of two-phase loop thermosiphons for thermoelectric refrigeration. It is a experimental and analytical type of work. When a direct electric current passes through a cell made of N-type and P-type semiconductor, one of the junction is cooled while the other is heated. This type of effect is known as Peltier effect. Two-phase loop type thermosiphon has been used for large-scale heat exchangers, and those of very small scale have been proposed for cooling of electronic and electrical items. Next slide. Now, if we conclude this experiment, the experimental result shows that the heat transfer results of up to about 29 watt per degree Celsius meter square, or about 5400 watt per degree Celsius meter square at the average air temperature of the refrigerator, 4.6 degrees Celsius, with an ambient outside temperature of 25 degrees Celsius, can be attainable under the forced convection heat transfer at a field evaporator and condenser section. Now, this was all my part. From here, Dilshad Alam will continue the presentation.
Hello everyone, this is Dilshad Alam, and the first paper I'm going to review is titled A Novel Approach for Optimization of Electrically Sealed Two-Stage Thermoelectric Refrigeration Systems Using Sharrow Algorithm. The type of work is analytical. So in this paper, the author has highlighted the need for optimization of thermoelectric refrigeration systems and surveyed several studies based on optimization of these systems. After reviewing this system, the author proposes a new optimization algorithm called the CRO, which is based on a chemical reaction mechanism. A brief overview of this mechanism is given, and then some mathematical modeling of the electrically sealed two-stage refrigeration system is done. To investigate the efficacy of this algorithm, a full computer code was developed, and two different test cases with different conditions were solved by it. COP and cooling capacity were the objective functions of the analysis, and since this algorithm takes a fair number of iterations for convergence of values, it is therefore a superior method, more accurate and more efficient for optimization of thermoelectric refrigeration systems. Next paper that I'm going to review is in itself a review on developments of thermoelectric refrigeration and air conditioning systems. This paper gives the introduction to the thermoelectric effects and its historical development as a novel RSC technology. Then it gives brief account of all the prominent developments in thermoelectric RSC systems and thoroughly reviews the latest research papers in the area. In the third section of the paper, the authors themselves perform a case study where they design and develop a thermoelectric refrigerator with a refrigeration space of 1 liter capacity. The COP of the experimental device was found to be 0.1. In the conclusion, authors discuss the effort made by researchers to optimize the thermoelectric RSC systems in order to overcome their limitations and such as low efficiency, high cost, and making suitable for commercial use. The final paper to be reviewed in this presentation is a study on the performance of a solid thermoelectric refrigeration system equipped with ionic wind fans for ultra-quiet operation. So authors highlight the adverse effect of high noise produced by compression refrigeration systems and emphasize the need for an alternative refrigeration system. One such system can be developed by replacing mechanical fan with the ionic wind fan in the thermoelectric RSC systems because they have low noise and high heat exchange coefficient. An experimental device developed using this technology and noise testing results show that the system operates almost noiselessly at the 4.2 decibel. Experimental results are also compared with the 2D simulation performed in Combs Hole, and the results were almost similar but little bit different due to 2D nature of simulation model. Results show that there is noticeable difference between optimum operating voltage for maximum air supply and max COP. So therefore, comprehensive testing of this proposed system is required for optimization of system performance. We are done with the review of 10 research papers which are on applications on limitations of thermoelectric refrigeration systems, which offer many advantages such as lightweight, flexible shapes, ability to both heat and cool, noiseless operation, and many more. So we have reviewed the papers in this area, which covers objective life, research and development of thermoelectric materials with high figure of merit, analysis and optimization of COP and rate of refrigeration by varying different parameters using different analytical and computational techniques, design and development of experimental devices for applications in advanced refrigeration systems, building, air conditioning, and ventilation systems, and attempts to develop efficient thermoelectric refrigeration systems coupled with other innovative technologies like ionic wind fans, nanotech, absorption systems, etc. These works promise an optimistic futures for RSC systems and motivate the researchers to take interest and develop more efficient thermoelectric refrigeration systems. Continuous efforts are being made by researchers for development of high performance and cost efficient thermoelectric refrigeration systems. If these efforts are realized in the near future, then it will bring a complete revolution in the RSC industry and disrupt the conventional RSC market. These are the references to the reviews, to the papers which we have reviewed. With this, we would like to thank you all for viewing this presentation, and we would also like to thank Professor M. Karim, who gave us this job from which we got so much to learn and to present you all to this great knowledge. Thank you.
Good evening, everyone. Today we are presenting our reviews on research papers on the topic cryogenic engine. This is presented by Group 8. Group 8 consists of Zurusha Mansoor, that's me, Sayyed Afan Ahmed,
and Fardeen Ahad Ansari. This review of research paper was made under the guidance of Professor M.N. Karimi, Department of Mechanical Engineering, Jamia Millia Islam. This is the index part. Here we can see that the first three papers were reviewed by Sayyid Afan Ahmed, and the fourth, fifth, and sixth paper was reviewed by Fardeen Ahad Ansari, and the last three papers were reviewed by me. Introduction. Cryogenics. Cryogenics is the study of production and behavior of materials at extremely low temperatures to lift and place the heavier objects in space, and the engine based on such a technique is called cryogenic engine. Cryogenic engine makes use of liquid oxygen and liquid hydrogen as propellants. Here we have on the left side of the screen a cryogenic engine model, and on the right side of the screen we have indigenous cryogenic upper stage of GSLV D5. Now Sayyid Afan Ahmed will start his review of research papers.
Thank you, Surusha. Hello everyone, my name is Sayyid Afan and I will be covering 3 research papers. The first one is titled as Linear Stability Assessment of a Cryogenic Rocket Engine. It is authored by Thomas Sattelmeyer. In this paper, linear stability of a cryogenic rocket engine is assessed using hybrid computation fluid dynamic, also known as CFD methodologies. A computer program was made to conduct the parametric performance calculations on namely power output, reject heat, and overall efficiency. The methodology introduced is capable of describing the acoustic propagation within the combustion chamber, the nozzle, and the propellant domes on the basis of realistic measures. Moving on to the next review, the title is Cryogenic Heat Engine Experiment. It was authored by N.C. Plummer. In this paper, experimental results on the operation of a cryogenic heat engine are presented. The system considered was very simple, consisting of only 3 primary components: a pressurized tank, a heat exchanger, and a pneumatic motor. Economic analysis showed that this system would be a remarkably viable alternative to the currently used gasoline system in such an energy-intensive industry. Moving on to the last review, it is titled Liquid Nitrogen Fuel Closed Brayton Cycle Cryogenic Heat Engine. It was authored by C.A. Ordonez. In this paper, a closed Brayton cycle liquid nitrogen power system was studied to prove its efficiency as a good alternative for power systems. In the work presented here, 3 Brayton systems were considered. For each, a monoatomic gas working fluid was assumed. It was concluded that closed Brayton cycle cryogenic heat engine have the potential to evolve into a new generation of non-polluting, cost-competitive vehicular and other mobile power systems, which is compatible both with the environment and with mankind's energy needs. Now I would like to invite Fardeen Ahad Ansari to continue with this review. Thank you.
Hello everyone, myself Fardeen Ahad Ansari, roll number 19BME069, and I'll be going to discuss 3 research paper review. The first one is Numerical Simulation of Cryogenic Injection in Rocket Engine Combustion Chamber, which is authored by P. Gillard. This paper mainly focused on oxidizer dispersion of organic fuel, which led to the dispersion of fuel into the droplets. The dispersion of fuel greatly influenced the flame shape. The numerical explanation is difficult to represent, hence specific models have been implemented to address such physical phenomena. Though this paper progress has been made in modeling and simulation of physical phenomena at work in the field of cryogenic combustion. Next slide, please. In this diagram, you can see two figures. The upper one, the lower one. In the lower one, you can see the yellow color flame, and in the upper one, you can see the pink color flame. The yellow one represents the experimental setup, and the pink color flame is shown. The pink color flame is represented by the CFD modeled flame. Next slide, please. The next topic of research paper is numerical study of conjugate heat transfer of a cryogenic methane in a rectangular engine cooling channel at a critical pressure. So in this paper, 3-dimensional conjugate heat transfer of cryogenic methane in a rectangular cooling engine channel was numerically investigated. The paper focused mainly on the effect of thermal conductivity of the solid channel material and the geometric aspect ratio of the channel. The result shows that thermal conductivity strongly influences the average surface temperature at the top channel, which is being depicted in the next figure. Here you can see on increasing the heated section, the thermal conductivity of the chamber decreases in the left side of the figure, in the left figure. And similarly, in the right part, you can see variation of cooling channel geometry produce significant effect on the surface temperature at the top channel. With increase in the heated section, the temperatures of the top surface increases. So the third paper is development of cryogenic engine for GSLV Mk3 and its technological challenges, which is authored by R.S. Praveen. This paper majorly focuses on the challenges faced when the first time cryogenic engine that operates in a gas generator cycle was developed by Indian Space Research Organization. The technological challenges faced during the various phases of development were briefly highlighted in this paper, and the system approaches adopted to overcome those challenges were also discussed in this paper. The paper focused on the development of engine that works on gas generator cycle, which has a flexibility of independent development, thus minimizing uncertainty in the final development phase with reduced development time. So you can see the integrated engine configuration model. Now I would like to call Surusha Mansoor to deliver her part. Thank you.
Thank you, Fardeen. Again, everyone, hello. Hi, I am Zarusha Mansoor, roll number 19 BME 065. I have done the review of 3 research papers. Firstly, I did the review of research paper titled A Cryogenic Gas Turbine Engine Using Hydrogen for Waste Heat Recovery and Regasification of LNG. This was authored by YSH Najjar. In this paper, certain characteristic of hydrogen is shown, which shows that it is convenient to be used as working substance in a closed gas turbine cycle, which recovers waste heat and delivers power and rejects the heat for evaporation of LNG to be ready for the further use. Sensitivity analysis shows that inlet temperature is more effective than compressor pressure ratio with respect to power and overall efficiency, whereas compressor pressure ratio takes over when rejected heat for evaporation is considered of main concern. Economic analysis shows that this system would be a remarkably viable alternative to the currently used heating system in such an energy-intense industry. This is the illustration of a hydrogen gas turbine. The second paper is Cryogenic Heat Engines for Powering Zero-Emission Vehicles. This was authored by C.A. Ordonez. In this paper, advancement of technology for using cold thermal reservoirs for mobile energy storage applications is shown. A heat engine as developed by the authors is also shown that can operate by using a subatmospheric temperature thermal reservoir such as liquid nitrogen as heat sink has been called a cryogenic heat engine. With sufficient work produced per unit mass of liquid nitrogen, such a cryogenic heat engine may be suitable for powering short-range, non-polluting automobiles. This is the illustration of a cryogenic heat engine. The third paper I reviewed was titled Flashing Behavior of Rocket Engine Propellants. This was authored by Garcia Lamana. This paper aims to present the morphology of flash atomizing jets during rocket engine operations. In this paper, both storable and cryogenic rocket engine propellants are taken for consideration, namely ethanol and liquid oxygen respectively. The result has many important indications. Firstly, it explains that jet disintegration at highly superheated conditions is mainly dependent on the kinetics of phase transition. Secondly, it also explains the variation in the degree of superheat at onset of a fully flashing regime between ethanol and liquid oxygen sprays, respectively. The low operating temperatures in cryogenic systems increase the energy barrier to nucleation. This is the illustration of a rocket engine. Thank you. Thank you for your attention. Kindly post your doubts in the comment section. We would be pleased to reply to them.
Hi everyone. Today Mehran, Ishrat and I are here to make a presentation on the topic analysis of parameters of green buildings. But before analyzing anything, first and foremost, we must ask, what is a green building? A green building is a building that in its design, construction, or operation reduces or eliminates negative impacts and can create positive impacts on a climate and natural environment. Here is another interesting question to ask. Who certifies and rates green structures? Different rating programs are in place in different parts of the world that fulfill this role. For example, India has got IGBC, GRIHA, BE, United States has got LEED, there is BREEAM in Europe, CASB in Japan, Green Mark in Singapore, and so on and so forth. Here is a list of some of the parameters on which green building is evaluated before being given a green rating. My analysis will cover the first 3 parameters, Mehran will go over the middle 3 parameters, and finally, Ishrat will look at the last 2 parameters. So, let's get going. The purpose of this study was to compare 5 international green building rating tools to better understand what measures help to improve site planning and development in green buildings using content analysis. Using the formulas shown in the slides, significant scores were assigned to each green building rating tool, and it was concluded that Beam Plus, which weights SPD at 25%, is the maximum among the selected GBRTs, and researchers claim that SPD strategies in green buildings can be further explored in future research based on the proposed theoretical framework. The second paper simulates an extensive double-story bungalow house located in Johor, Malaysia, using Revit Architecture 2012, and then calculates the house's annual operational energy consumption using ecotech analysis. The total energy to keep the building's temperature between 22 to 26 degrees Celsius was calculated to be 17,600 kilowatt hour. According to the results of the study, alternative materials could lower the annual amount of energy used by the building to 12,850 kilowatt hour by replacing the baseline design with a thoughtfully designed alternative design. Now, for the third paper, it describes the basic concepts of green building and discusses the role of HVAC in ensuring high-performance sustainable buildings in designs and operation. The design strategies for effective and green HVAC systems are explained, and the new emerging HVAC technologies for green buildings are described, namely underfloor air supply systems, desiccant-based cooling systems, gas-fired refrigeration plants, demand-controlled ventilation, solar cooling, and refrigeration. That's it from my side. Now over to you, Mehran.
Thank you, Farna. Hello everyone, I am Mehran Firoz and I will be reviewing 4 research papers on the parameters of green building. So let's start with the first paper, which is solar water heating system with phase change material. Author of this paper are Atul Sharma and C.R. Chen, and the year of publication is 2009. So one of the most widespread uses of solar thermal technology is solar water heating. India is blessed with good sunshine. The country receives solar radiation amounting to over 5 into 1015 kilowatt hour per annum, with the daily average incident energy varying between 4 to 7 kilowatt hour per meter square depending on the location. Since the solar energy supply is variable in daytime and zero at night, so considerable amount of solar energy should be stored during the daytime to meet the demands at night. Energy storage is therefore essential to any system that depends largely on solar energy. Solar radiation cannot be stored as such, so first of all energy conversion has to be brought about, and depending on this conversion a storage device is also needed. From this paper we concluded that the solar water heating system plays an important role in sustainable energy management in Indian households as well as worldwide. Such an effort will not be only useful in improving the quality of life but also in environmental protection. This review paper is focused on past and current research of energy storage through PCMs for solar water heating system. This paper will help to find a suitable PCM and provide the various designs for solar water heating system to store the solar thermal energy. Now the second part is based on paper comparison on efficiency of various techniques in treatment of waste and sewage water. Water is one of the most important substances on earth. All plants and animals must have water to survive. If there is no water, there would be no life on earth as well. Due to industrialization and urbanization, it is becoming more polluted, and risk of this polluted water consumption and its sanitation problem is increasing day by day in most of the developing countries. Hence, it has become an essential need for today's environment to protect water from getting polluted or to develop cost-effective remedial method for its protection. From this paper, it is concluded that the conventional techniques are not efficient in reducing the toxic heavy metals, nitrogen, phosphorus, etc. There is no unique method to treat most of the compounds in a single step. Quantification of metal biomass interactions is fundamental to the evaluation of potential implementation strategies. Hence, sorptions, isotherms, ion exchange constants, as well as model used to characterize algal biosorptions are found to be very important towards treatment of wastewater. Now the third paper which I am going to review is based on indoor environmental quality in KGBC certified office buildings by occupant satisfaction and performance. KGBCC stand for Korean Green Building Certification Criteria. The study results showed that the most demographic and personal workspace characteristics of respondents were similar between KGBC certified buildings and non-KGBC certified buildings. Indoor air quality, indoor public space, thermal comfort, and noise and acoustics are the 4 IEQ criteria of the KGBC certification. However, in case 1, there was no significant difference in KGBC IEQ criteria with regard to satisfaction and performance enhancement between the KGBC certified and non-KGBC certified buildings. In case 2, all of the KGBC IAQ criteria had shown significant differences in both satisfaction and performance between the KGBC certified and non-KGBC certified buildings. The study analyzed 2 KGBC certified office buildings with best and good certification grades. Both buildings had higher overall satisfaction and performance enhancement scores than the non-KGBC certified ones. Now the last topic which I am going to review is based on renewable energy utilization evaluation method in green buildings. The theory of green building includes a lower environmental load, higher energy efficiency and resource saving throughout a building's whole life cycle. At the same time, green buildings should provide comfortable and safe and healthy environments for people as well. Utilizing renewable energy is an important part of the design and development of green buildings. In this paper, the energy quality coefficient is introduced to describe the quality of energy, while the energy conversion coefficient is applied to evaluate energy system efficiency. The indexes and their expressions were developed based on energy analysis. Based on these 2 indexes, an effective substitution ratio was developed for the evaluation of renewable energy utilization. That's all from my side. Now I would like to invite Ishrat to continue the rest of the presentation.
Hey everyone, my name is Ishrat Nigar. I'll be reviewing 3 papers of this presentation. In the first paper, as you can see on the slides, one of the principles that are adopted is using materials that are sustainable or green. As per IGBC, a green building uses less energy, water and natural resources, create less waste and it is healthier for the people living inside compared to the standard buildings. The components of the green building include material efficiency, water efficiency, energy efficiency, indoor air quality efficiency, waste reduction. From the above, it is clear that all the efforts made for conservation of environmental resources is considering a step towards green and sustainable materials. The rating system GRIHA or LEED certification therefore demands the use of sustainable materials. In the second paper, in this period of time when there exists a trend of decreasing the energy consumption, not only from the aspects of cost, but primarily from the viewpoint of the accessibility of their sources. Green building considered interchangeability effective resources with a minimum negative influence on the environment are the urgent problem of the present times. In the third paper, the IEQ benefits of the green building translate to better self-reported health and outcome across several indicators. This include fewer sick building syndromes, symptoms, fewer respiratory symptoms reports in children, and better physical and natural health. So these are the references from where we collect our materials in this presentation, and thanks everyone for listening carefully. Thank you.
Okay, hello everyone, I'm Mohammad Shadab, a third year mechanical engineering student of Jamia Millia Islamia. The other members of the group are Faizan Ansari and Adnan Qayyum Khan. Today we'll be reviewing some research papers based on the topic air conditioning systems in aircraft. So the following slide we attempt to bring light to the assigned topic by going through the related research currently taking place in this paradigm. Along with this, we will also define some gaps in knowledge and prospects that may need further research in future. The presentation takes in form of 3 iterations, each iteration detailing findings and summarizing 3 works of scientific study. So let's start with the first iteration. The first paper is thermodynamic study of aircraft air conditioning air cycle machine, 3-wheel versus 4 wheels. This is a simulation type of paper. The main objective of this paper is the development of aeronautical air conditioning system thermodynamic models of 3- and 4-wheel air cycle machines, which aims to understand the main thermodynamic advantage and disadvantages of each configuration. The result showed that the second level of expansion from 4-wheel air cycle machine increases the thermodynamic efficiency of the cycle, and this effect was more evident for ground operation conditions. In addition, it was also observed that the presence of the condenser decreases the coefficient of performance of both air cycle machines discussed, which is related to the fact that the lines of constant pressure on a TS diagram diverge with increasing entropy. Let's see the second paper. A data-driven health indicator extraction method for aircraft air conditioning system health monitoring. This is an analytical type of paper Prognostics and health management (PHM) has become a very important tool in modern commercial aircraft. Considering limited built-in sensing devices on the legacy aircraft model, one of the challenges for airborne system health monitoring is to find an appropriate health indicator that is highly related to the actual degradation state of the system. The case study result shows that the proposed health indicator can effectively characterize the degradation state of the ACS, which can provide valuable information for proactive maintenance plan in advance. Let's see the next paper. Aircraft air conditioning, heat exchangers and atmospheric fouling. This paper describes how the aircraft air conditioning system functions, such as those on the A320s, including the components within the system. The need of an air conditioning system requirement is explained, including the use of external airflow from outside to act as a cooling source, which is also known as ram air in technical terms. Fouling collected from large commercial aircraft is analyzed using different techniques to identify the potential source of emission and composition. This paper addresses the failures of the ECS due to the fouling, identify the potential sources of fouling and operational measures that may affect this safety critical system. Now Faizan will continue from here. Over to you, Faizan.
Thank you, Shadab. From here, I will continue my part. My name is Faizan Ansari and I have reviewed 3 papers specifically on air conditioning system of aircraft. The first system is aeronautical environmental control system that controls the temperature, humidity and pressure to maintain the comfort for the people and ensures the proper functioning of equipment. It also provides anti-icing oxygen system and fulfill other pneumatic demands in aircraft. The other ECS system is APU, that is auxiliary power unit, which is a separate gas turbine but having no thrust. It provides the electricity to ensure the functioning of air conditioning when plane is parked. Next slide please. In the second and third paper, I have reviewed the air conditioning system of an aircraft, from which the first one is vapor compression cycle system. Vapor compression cycle system is based on modified Rankine cycle, which is operating in reverse. Here, refrigeration cycle run by electric motor driven compressor. In this system, no fresh air is provided by air conditioning system because we use chemical refrigerant as a working fluid. In short, there is air recirculation occur to reduce the heat load in aircraft. Next slide please. So the second cycle of AC in aircraft is air cycle system. It is based on open reverse Brayton cycle. Obviously, the ambient air is refrigerant here, as the name suggests. The compressed air from aircraft engine is used as a power source here. Either fuel or external aircraft environment is used as a heat sink in this case. So here's my part is completed. Over to you, Adnan.
Thank you, Faizan. I will now be continuing on to what is now the third iteration of the literature review. The first paper being an analytical study on the parked aircraft air conditioning systems. Now, when the passengers have to board the aircraft to ensure their comfort, the aircraft has to be pre-cooled. So for that, this paper deals with the pre-cooling of the aircraft and how the air conditioning systems will function. So two basic cases were defined, one being how the ambient temperature in the aircraft will be maintained during winters and during summers. In summers, the outside temperature is set to be 35 and in winters -1, and the temperature that is maintained in the cabin is from 24 to 21. And based on this, the type of parameters of the load that influence. The third paper is a simulation based study which deals with the Airbus A320 model, wherein the nozzles which are kept above the passenger seats, which are responsible for supplying the air, are analyzed, and their attenuation for the airspeed and how much velocity and how much area is covered by each nozzle at a particular time on different cross sections and different angles. These are considered, and some results that come out of the study are that for a distance of less than 0.4 meters, a sharp attenuation area was marked where velocity of air slows down. Then between distances of 0.7 to 0.9 meters, the velocity remains about 1 meter per second with the vents fully open and half the speed, 0.5 meter per second, when the vents are half open. Next slide, please. Right. So from these papers, now we have derived some potential scope for future research work. The first one being about the paper that Shadab had discussed in his first iteration, the second paper about maintenance. And in the domain of maintenance, the air conditioning system can be monitored, maintained in a more robust fashion if past data is used. The second being about the hybrid systems that make use of both vapor compression cycle and air cycle systems to provide the cabin with conditioned air. This is with regards to the second iteration, which was discussed by Faizan. And the third one being the reliability of aircraft air conditioning packs can be better assessed if cyber-physical systems are taken into account for making more accurate data points, and machine learning is utilized for finding out the outliers behind the failure. This is with respect to the third iteration, the second paper. Right. In conclusion, the air conditioning systems in aircraft provide an ergonomic experience and optimum comfort to all passengers. It is also necessary for cooling of all the avionic systems on board. It also plays a major role in relaxing all the cabin staff and the pilot, and increases human efficiency. However, the mechanisms involved in delivering optimum level of air and those involved in maintenance are areas that serve as exploratory grounds for further research and development. Next slide. So these are the references that were used for our research literature review. Next slide, please. Right. Thank you all. Thank you for listening.
Good afternoon and respected sir, my dear all friends. My name is Mohammed Fazan and these are my group members Amjad and Parvez. Today we are all here for presentation of refrigeration air conditioning. The topic is balancing of chill water. Next. Now I will explain what is the chill water system. Chill water system provide cooling to a building by using chill water to absorb heat from the building space. At the heart of the water chill system, a chiller removes heat from water by means of refrigeration cycles. Basically, chilled water system are generally used in medium and large size of building, and chiller plants acts as centralized cooling system, provide cooling to or even multiple buildings. Next. Now I will give short review of the research paper optimizing the number of pumps and balancing valve in chilled water distributing system. According to statistical data, electrical energy consumption of pumps might be up to 17% of entire electrical use of the cooling plant. Cooling system load will not be same all the time. Variation must be treated accordingly. Just like the temperature is not same everywhere, temperature is change according to time. And therefore, to get best efficiency of the system, we must get a good control. Besides, shut off the motorized valve and power balancing must be considered in different scenario. In this paper, they tell us about how to increase efficiency of chill water and how many numbers of pumps and a balancing valve can be used increase efficiency of chill water distribution system. Practical example of zoning, on-off control valves and modeling control valves. Next. And here the conclusion of this research paper, optimizing of hydraulic loop does have focus on dynamic data of flow, and important aspect of a distributed pumping solution is that balancing is easier for entire loops. System safety is better if one pump fail and other can continue serving their area. So only small parts of the building loop will be multifunctioning. Next. Now I will give the short review of this research paper, a simple and quick chilled water loop balancing for variable flow system. First, method of simple and quick balancing of chilled water riser for a large medical facilities has been developed and implemented. Through water loop commissioning and the cold air temperature is maintained very well, and the energy consumption for a pumping system is reduced by about 40%. The traditional method of balancing the chilled water loop set the variable speed pump to full speed and the cooling coils valves to their full or open positions. For most cases, through traditional balancing, the manual balancing valves are adjusted to the partially open position and will remain in the dead position until somebody adjusts it later. Sometimes the valves remain at 50% open. or less for each floor. So, traditional approach to the system balancing thus negates some of the benefits of installing variable speed drives. Through the commission of process, the author developed a new approach to quick balancing and chill water riser if the riser are equipped with VFDs. Next. Here, the new approach of balancing the variable flow chilled water riser. The first one is fully open the entire manual balancing valve for each coil on each floor. And second is optimize the differential pressure AP and set point based on the riser layout and AF sensors, let's say sensors locations. And third is after the implantation of the new set point, check the coil deck temperature for each coil, the AF for the furthest coil, critical coil or any special coil. Make sure that this is good coil deck temperature and control and enough AP for each coil. And identify each faculty sensor, faulty sensor and valve and any control problem for coil control valve. Repair any that are multifunctioning. 5 is fine tune the set point based on the actual load condition and control result. Next. And this is the conclusion of this paper. The quick and simple balancing approach to the balance variable chilled water riser to the chilled water loop was developed by the author and was also applied to commissioning project. Approach considered the real system layout and operating condition of the riser or loop when compared to the traditional balancing method. This new approach can reduce the pumping power consumption much more and make the VFD conversion payback much shorter. If the delta P sensor is located 2 by 3 piping distance down, the stream from up, and the reset scheduler delta P is recommended. The reset delta P can be based on the load condition or outside the air temperature. Next. And here the application of the all papers, the buildings, and the building is multifunctional estates and arts medical center with gross area of square feet, and the building was mostly occupied in late 1996. The whole complex primarily consists of outpatient and clinic room, pharmacy, nuclear medicine, ICU, and surgical areas. Now, I will hand over this unit to my friend Parvez Alam.
Thank you, Sajjan. Hello, everyone. I am Mohammad Parvez Alam Khan, and I am going to review this paper number 3. And the topic of this paper is differential pressure, bypass shield, or heat water system, criterion and the procedure for balancing. The author of this paper is K.K. Love and others. And now I will tell you about the other description of this paper. The paper is about the criteria and the procedure for balancing differential pressure bypass, chilled and heating water system. Theoretical analysis has been carried out. We suggest that the proposed criterion is feasible. The drawback is that the slight oversizing of coils is required. Advantages are simplification in balancing procedure and achieving a higher operating differential temperature across the mains than the system design value, which would allow chillers or boilers to operate to their design thermal output. Okay. Now moving to the application part of this paper. In most chiller application, water-cooled condenser uses a cooling tower to reduce the temperature of the condenser. In this case, the water loop system is separated from the chill water that goes to the building. The water is then sent to the cool tower by the use of pump to be cooled by evaporation of the water in the cooling tower. The cooled water temperature now drops to 85 degrees Fahrenheit or 29 degrees Celsius and enters the condenser again. This process is repeated and repeated again. Now, moving to the conclusion part of this paper, theoretical analysis has been carried out. We suggest that the proposed criterion is feasible. It means that our proposed criterion is feasible and can take place. The drawback of this procedure is that slight oversizing of coils is required. Advantages are simplification in balancing procedure and achieving a higher operating differential temperature across the mains than the system design value, which would allow chillers or boilers to operate to their design thermal output. Now, moving to my second paper. The second paper is the topic of the second paper is parametric studies on thermally stratified chilled water storage system, and the author of this paper is Brian J. Murray and others. This paper is about the pump differential pressure can be continuously optimized based on the position of the control valve, striving to keep one valve almost completely open at all times, minimizes the pumping energy. While this may cause some valve hunting, the overall performance of the chill water system remains good. Now moving to the application part, the chill water is piped into fan coils unit which consists of fins and fans with large surface area that absorb heat from the space through the air heat exchange process. Each fan coils unit has its own thermostat that regulates the amount of cooling needed. The chill water got heated and returns to the chiller at about 55 degrees Fahrenheit and 13 degrees Celsius. The water temperature has been heated up to 10 degrees Fahrenheit or 6 degrees Celsius after cooling the space. Absorption chillers should only be used where there is an abundance of high quality waste heat or cheap heat. They are often found in hospitals and buildings with heated swimming pools. Now moving to the conclusion part. The conclusion of this paper was the above process may cause some wall hunting. The overall performance of the chill water system remains good. Now I am handing out this presentation to my friend Amjad. Now Amjad will present.
I am Sheikh Mohammad Amjad, and I will explain my research papers. So the first research paper of mine is synthesis and design of chilled water networks using mathematical optimization. The efficient use of chilled water with opportunities for reuse, recycling was explored in order to lower the overall chilled water flow rate supplied to the network. Based on a superstructure that includes all possible network connections, mathematical models are developed for different integration schemes. Other than minimizing the chilled water requirement, a conflicting objective is included in the model to reduce network complexity and to improve flexibility. The design problems are formulated as mixed integer non-linear programming models. Two industrial cases studies are used to illustrate the purposed approach. Next slide. So now the applications. In warmer climates, chilled water systems can be used in a place of standard air conditioning in order to achieve and maintain more comfortable interior temperatures. Piping connects a chiller to cooling coils within an air handling unit. Air is cooled here via the chilled water within the coil and then distributed throughout the building via series of ducting systems. This creates an eco-friendly solutions to cool down the home. Because chilled water systems are great for cooling down multiple separate individual areas, it's perfect means for maintaining temperatures in large apartments, blocks, and hostels too. Once the water has cooled down, the air it returns to the chiller in the region of 13 degrees centigrade. The chilling process begins once again, either on a timer or at a request of an individual. Next slide. So here is my second review and research paper. Energy optimal control of bilinear multi-zone cooling system with chilled water storage. The optimal control of multi-zone fan coiling systems with chilled water storage. Let me explain with an example of a system consisting of two environmental zones, a fan cooling unit for each zone, a chiller and a storage tank, pumps and distribution network. The bilinear model of a system is linearized through use of state feedback. The method of state increment dynamic programming augmented with a label tracing procedure. There are many particles consideration for the implementation of these methods in a feedback controller for a multi-zone cooling system. Next slide. So what is a multi-zone? Like its name suggests, multi-zone cooling system are used to separate different climate controls areas in your room. This means you can have one temperature in your living room and another in your bedroom. It's a great setup for a big families who can decide on a temperature that makes everyone happy, as well as families who have number of members with temperature sensitive lungs. Thanks to added flexibility, these systems allow for truly personalized home comfort. So the conclusion is efficient use of chilled water with opportunities for reuse and recycling was explored in order to lower the overall chilled water flow rate supplied. In piping system, as I explained, in piping system, air is cooled via chilled water within the coils and distributed throughout the building. And multi-zone systems can be configured any number of ways, and the demands on your current system or your current new system depend on how many zones you want to set up. It's common to have rooms that are used less than others, such as guest room, bedrooms, and bathrooms, set to different temperatures than more heavily trafficked areas. And here are the all the references which I have taken to complete this presentation. And thank you everyone for having us.
Good afternoon, everyone. This is Mohammad Nabil Firoz on screen with other two companions, Shadan Diaz and Fahad Nasir. We are here to give presentation on energy recovery system in air conditioning. The topic was allotted by our professor Munawwar Nawab Karimi. So before wasting any time, let's dive into the topic. Next slide. Let's have some background about this. What is an energy? Energy is an essential requirement for growth, movement, maintenance, and creating work. Energy has become a requisite part of human activities. We have reviewed some of the research papers, and in one of the research papers written by Dima Friti, giving emphasis on energy consumption. In residential and commercial building, energy consumption has escalated firmly. The main reason for this was due to the HVAC system in those buildings. Consumption of HVAC contributes to EMS, called Energy Management System. In her review, she analyzed that energy recovery situation in COVID times, stating that heating, ventilating, and air conditioning system, which consume around 39% of energy in the residential sector, have turned into an essential constituent for providing fresh air, especially after COVID-19, not only in hospitals, but also in any simple constructions. Next slide. Coming back to the topic, energy recovery ventilation. It's an energy recovering process in residential and commercial HVAC systems that exchanges the energy contained in normally exhaust air of a building or conditioned space, using it to treat the incoming outdoor ventilation air and the specific equipment involved, ERV, called energy recovery ventilator. It's a typical diagram showing the representation of air movement, how it varies. Next slide. So there's a question arises, how does energy recovery work? Energy recovery system use the energy in buildings, energy in building air that would normally be exhausted to treat the incoming ventilation air. The system works differently in summer and winter. During warmer season, the system pre-cools and dehumidifies the incoming ventilation air by sending the rejected heat into the exhaust air stream to cool the condenser coil at a lower temperature. But during cooler season, the system uses the heat from the exhaust air stream to preheat and humidify the incoming ventilation air. So this is from my side. Now Shadan will continue from here.
Thanks, Nabil. Good morning, all of you. This is Shadan Riaz. Till now, we have discussed a lot about the energy recovery, the need of an energy recovery, and how does the energy recovery works. So let's discuss about some of the technologies that is used for this energy recovery. And we will confine our discussion to rotary wheels and flat plate exchangers. Let's begin with rotary wheels. So the figure here is depicting the rotary wheel. Our air-to-air energy recovery wheels consist of a rotating cylinder filled with an air-permeable material between the ventilation and exhaust air streams. As the wheel rotates, it draws in heat and energy and releases it into the colder air stream. Next slide. In this slide, we are going to discuss the flat plate exchangers. You can see here the model showing the flat plate exchanger. The flat plate exchangers consist of alternating layers of plates that are separated and sealed with a heat energy recovery probe treating incoming air. Our flat plate exchangers are offered in three substrate material options: aluminium, polypropylene, or heat and moisture. In this slide, I am going to discuss the other paper reviewed by us. The topic of this paper is testing for energy recovery ventilators and energy saving analysis with air conditioning systems. The author was Peng Yang and others. In this, the author have emphasized mainly on energy recovery ventilators and the techniques to save energy. The energy recovery ventilators is mainly used to reduce the energy consumptions associated with the conditioning of ventilation air. The higher rates of the ventilation rate provides better indoor air qualities. The ERVs reduce indoor air pollution of modern buildings, improve indoor work and living environment. The fresh air ventilators to the exhaust air of air conditioning system is increasing fresh air while saving energy, improving indoor air qualities. Now Fahad will continue from here.
Thanks, Shadan. This is Fahad Nasir, and I believe everyone might have understood two research papers up till now. So in continuation of this, I am going to review some more research paper. Here is the third one entitled as Energy Recovery from Diesel Engine Exhaust Gases for Performance Enhancement and Air Conditioning. This research paper is written by M. Talvi and B. Avenue, In this research paper basically explores theoretical performance of 4 different configurations of a turbocharger diesel engine and absorption refrigeration unit combination when operating in high ambient room temperature. While they also laid emphasis on utilization of exhaust waste heat. Obviously, this research was simulated and the simulation is performed using SPICE. This is a well-known program commonly used for engine performance predictions. Now, the paper examines interfacing of the turbocharged diesel engine with an absorption refrigeration unit. Also, it examines the influence of the cycle configuration and performance parameters. This paper demonstrates that a pre- and intercooled turbocharger engine configuration cycle offers considerable benefits in terms of SFC, efficiency, and output for the diesel cycle performance. Now, this is the last paper which we reviewed. It was written by Fabrizio Ascione and other, having title Energy Saving Strategies in Air Conditioning for Museums. In the museum environment, a strict thermal hygrometric control is necessary. First of all, for correct artwork consumption, and second for visitor thermal satisfactions. Now, they also laid emphasis on good dynamic microclimatic control. In this paper, a case study was presented on various strategies to reduce energy requirement for HVAC systems in an exhibition room of a modern museum. Using dynamic simulation for DOE 2.2 and other typical climatic hourly data sets are also used. The major emphasis on this research paper was the proper use of desiccant system and also the use of HVAC system with demand control ventilation, how it should be properly used, how it should be maintained, and other basic criteria. So yes, that was all about our research paper which we reviewed. Now we will look into the benefits of energy recovery system. These recovery systems basically they improve indoor air quality. They are also used in energy consumption and energy savings. They control moistures and lastly compliance. That is, energy recovery systems must meet the HDA ventilation and energy standards. Yeah, that was all our presentation. These are the references. You can, if you want any higher vision in that, you can just go through those research papers and you have a basic idea about that. Yes. Now, ending this presentation by a beautiful quote by David Cameron stating that in a race for limited resources, it is the energy efficient that will win the race. Thank you.
Everyone, today we are going to make a review of paper 3-pipe versus 2-pipe system in chilled water circulation. So let's begin with it. Now, we are going to speak about our mentor, Professor Dr. Munawar Nawab Karimi sir, the person who always guided us in all the ways possible according to the need of the students. So this is a Google Scholar link of our professor and this is the university website. So our team members in this presentation are going to be Saima Siddiqui, Himanshu Minru, that's me, and Akram Faz. So let's begin with it. Introduction about the topic. A chilled beam system can be used for ventilation, cooling, and heating of the office building for thermal comfort. In this project, the possibility of using the same pipes for both heating and cooling are investigated, depending upon the requirements pertaining to the heating and the cooling seasons. The main objective of this project is to study requirements, possibilities, and limitations for a well-functioning 3-pipe versus 2-pipe system in chilled water circulation. Now, what is 3-pipe or 2-pipe? 2-pipe can be simply used for heating and cooling a simply large building. That means you have no control which rooms you want to heat up and which rooms you want to cool. But in 3-pipe, it depends upon the users. That suppose if a building has 10 rooms and there are 3 people, 3 rooms which are feeling cold and there are 3 rooms which are feeling hot. So you can adjust them like according to your choice. Like I want to make this room heated up and I want to make this room cold. Now this is what 3-pipe and 2-pipe are contradicting each other. Now let's begin with our presentation. Thank you. Let us begin with the research paper. Theoretical and experimental investigation of wickless heat pipes, flat plate solar collector with cross flow heat exchanger. Now, in this paper, the earlier experimentation was done without heat exchanger. That means without the help of cross flow heat exchanger. But in this review, we are doing with the help of a cross flow heat exchanger. The comparison between these two results are drastically high, and this has been tested under different climatical conditions, and they are very close to ASHRAE standard mass flow rate for testing, and hence this one predicts that the experimental investigation of wickless heat pipes, flat plate solar collector with cross flow heat exchanger is considerably better than the standard one. Now, the ninth one that is shown over here is use of nanofluids. Now, nanofluids technique is a most better and good alternative to the conventional heat transfer medium. This is done by addition of nanoparticles of high thermal conductivity to the blaze fluid of the low thermal conductivity. The process was used to prepare Al2O3 water nanofluid. Al2O3 nanoparticles was added with water in the cooling tank through using different concentration by weight varies from 0.1, 0.2, 0.3 and 1% weight, and this also show a considerably great result. Now the 10th one is thermal coupling and its effect on the total delta T of chilled water system with the fan coil units. Now the chilled water circulation system with fan coil units suffer from a low temperature differential between the supplied and the returned water, and hence on-site investigation shows that relationship between total cooling consumption and total water flow rate on real system is different than that of a single coil units, mainly as a result of interaction of the terminals. It is like observed that when the other terminals having high flow rates and lower water delta T values are considerably low when certain terminals are closed. System coupling factor is used as an indicator to describe the total degree of fan coil unit coupling in a system. To observe the effect of the system coupling factor, a dynamic stimulation platform is constructed and stimulated tests are performed, and hence we can see the difference over here clearly. Thank you.
Experimental and numerical studies of heat and mass transfer performance and design optimization of fan coil with high supply chilled water temperature in air conditioning system. Rising chilled water temperature contributes to improving the energy efficiency of the water chilled in air conditioning system. This paper experimentally investigates the changing evolution of both cooling and dehumidity capacity of fan coil in AC system, indicating the capacity of 3 rows fan coil declines when rose from 9 degrees Celsius to 12 degrees Celsius, which cannot satisfy the requirement of indoor comforts. Constant flow rate charging characteristic of a full-scale esterified chilled water storage tank with double ring slotted pipe diffuser. Temperature distribution formed during charging of a 14-meter water depth, 7-meter radius esterified chilled water storage tank with double ring octagonal slotted pipe diffuser were recorded and analyzed. Prior to the beginning of each test, the tank was fully discharged and at a relatively uniform temperature. To the extent possible, inlet flow rate and temperature were held constant during each test. 6 tests were performed for flow rate varying from 50% to 95% of design. Thermal performance was quantified using thermocoil thickness, half cycle figure of merit, and equivalent lost tank height. The thermal performance for all tested charge flow rates was good by current standards. Thermocline thickness for low and medium flow rates was relatively small, on the order of 1 meter. Erroneously large thermocoil thickness measurements were obtained in the high flow rate case because of the effect of inlet temperature variation combined with the definition of used.
everyone, this is Salma Siddiqui and I am going to review the paper based on 2 pipe versus 3 pipe in chilled water circulation system. So, as part of ASHRA research project 1185 field data from the constant flow rate, charging of a stratified chilled water storage tank with double ring octagonal slotted pipe diffusers serving a university chilled water system were compared with results computational fluid dynamic model, that is also known as CFD model. It is also shows that this is due to inheritance between a flow controlled by multiple three-dimensional jets in the actual diffuser and jets in and continuous slot of the axisymmetric model. The effect of turbulence varied from negligible to moderate as the Richardson number decreased. An experimental study was conducted to determine Nusselt number and friction factor on the air side of very fine chilled water cooling coils. General correlation of the dry surface Nusselt numbers and friction factor were developed from the data obtained from 5 different cooling coils. Friction factors were substantially higher under wet surface condition. A correlation to predict like friction factor for wet surfaces was also developed. A case study based on the building in Hong Kong is conducted to demonstrate this.
Ever been in a metro with its AC not working? If you have, then you'd understand the importance of air conditioning in underground metro systems. Hello everyone, I am Mohammad Shakib and today I am here with my friends Yavar and Sarin to deliver a presentation on the topic underground metro air conditioning. Today we'll be talking about air conditioning in underground metro systems and we'll be reviewing research papers based on them. So without further ado, let's get started. First, we'll be talking about the needs for air conditioning in underground metro systems. As we know, the underground stations of the metro corridor are built in a confined space. A large number of passengers occupy converse halls and the platforms, especially at the peak hours. The platform and the concourse area have a limited access from outside and do not have natural ventilation. That is why we need to have supplying fresh air for the physiological needs for passengers and the authority staffs. We also need to remove body heat, obnoxious odors and harmful gases like CO2, etc. There is also a need to remove large quantity of heat dissipated by the train equipment like traction motors, braking units, etc. Next slide please. Now let's look at the external environment conditions that we should consider while setting up VAC systems. Climate conditions of the region should be considered. That is, we take note of the summer months when the temperature would be relatively high compared to the rest of the year. We need to take care of the air pollution level of the region while designing the VAC system. We also need to take into consider the temperature of the subsoil region. Next slide please. Now let's come on to the first research paper, that is review of passive strategies for ventilation and air conditioning energy saving in underground metro stations. This was authored by Yamze Yu among others, and it was experimental paper type published in the year 2019. The purpose of this paper was to provide an overview of passive ventilation and air conditioning energy saving measures in underground metro stations. Building envelopes, the piston effect and natural cold sources were all addressed in these strategies. The conclusion was this work gives a detailed overview of passive solutions for reducing VAC energy used in underground metro stations. In the scientific community, the piston effect was the most preferred passive method. Next slide please. Now let's come to the next review, that is economical control of indoor air quality in underground metro station using an iterative dynamic programming based ventilation system. It was authored by Min Jeong among others. Paper type was experimental and it was published in the year 2015. The ideal set points of the ventilation control systems were identified in this system in the study to keep indoor air quality at a tolerable level while reducing ventilation and energy consumption. The conclusion of this paper was that IAQ ventilation control system controlled with IDP-based optimal set points can provide reliable ventilation performance while lowering energy consumption in metro stations. However, the parameter that may affect the PM10 concentration in the subway station are not taken into account in this study. Next slide please. Now let's come to the review of research paper 3, that is ventilation and air conditioning system of deep buried subway station in subtropical climates. This was authored by Hua Yin among others. Paper type was experimental and it was published in the year 2020. The characteristics of power consumption, load and temperature in subway VAC system were investigated in this work by detailed field research, environmental monitoring, heat dissipation detection and power log processing, etc. The conclusion that we had was this research is part of an energy saving research effort for ventilation and air conditioning systems in subway stations that aims to bridge the gap between low energy efficiency and high energy saving demands. Now I would like to hand over this presentation to Yavar to continue with this presentation. Thank you.
Thank you, Shakir. Hello, everyone. I'm Yavar here to discuss the review of the research paper on the underground metro air conditioning. First research paper says about reducing consumption for heating, ventilation and air conditioning in the underground metro stations. It was authored by Yan Zhe Yu. As stations are increasing rapidly nowadays, there is a need to reduce its energy consumption so as to divert it for other purposes. Now, the paper provides for the platform doors, air wells, and being classified them as the passive strategies. We can also use DX air condition. The amount of fuel saved can be used for other purposes of the mankind and can be proved as a boon to us. Slide change. The second paper deals with the characteristics of indoor air quality in stations authored by Amit Fasi. The underground metro stations have 2 to 10 times higher concentration of indoor air pollutants. The bacteria growth was also there, so measures like air supply rate of 8 LSP must be maintained. Otherwise, there is an exposure of BTEX, formaldehyde, acetaldehyde, etc. Studies have shown that it may include mechanical ventilation systems, including air filtration units that can be implemented as a built-in building direction. Next slide, please. The next paper gives a brief about thermal comfort field study, which was done on the subway passengers during AC in Beijing, a city of China. It was authored by Song Pan. It proposed a method to study dynamic thermal comfort for Beijing metro. It concluded that average temperature inside the metro is V-shaped. The thermal comfort temperature ranges from 26 to 29 degrees Celsius at the entrance, 34.5 to 28.5 on the platform, etc. There is a linear relationship between air temperature and thermal sensation. Now, I would like to hand over the discussion to Sarim Hashmi for further continuance. Thank you.
Thank you, Yavar. Hi everyone. This is Sarim Hashmi, and I will be reviewing the paper number 7 titled Air Change Rate Effects on the Airborne Disease Spreading in Underground Metro Wagons. This paper is authored by El Salomon, and the paper type is experimental, and it is published in year 2021. The goal of this paper is to study the transport of the cough-generated aerosol from patient in a metro wagon subjected to different scenarios of ventilation rates and patient position and make the recommendations on the ventilation for reducing the risk of infection of COVID-19 or similar airborne diseases like flu. The conclusion of this paper is that as the HVAC inlet flow increases beyond a certain value, the infection hazard does not so much difference. Change in ACPH value from 0.7 to 0.94 reduces the WVR from 6% to 2% after 10 minutes. And the most important point of this paper is that by keeping the windows open and increasing the volume flow rate above the average, we can reduce the rate of infection by a significant amount. Now, next paper. The next paper is paper number 8 is titled Flow Patterns and Temperature Distribution in an Underground Metro Station. This paper is authored by Hassan, and the paper type is experimental, and it is published in year 2018. The goal of this paper is to improve the thermal comfort of passenger in all modes to an acceptable level. The conclusion of this paper is that the hybrid system will save 2.54% of electric power that would consume to cover the worst condition. Depending on the CAV value, actually it will save 32.9 kilovolt. The hybrid system will save up to 7.5% of the electric power. Now, next paper. The Paper is titled on the determination of thermal comfort conditions of a metropolitan city underground railway. The goal of this paper is written by George, and the paper type is experimental, and it is published in the year 2016. The goal of this research is to look at the thermal comfort conditions of the unique and complicated underground train environment, field measurement of air temperature, air humidity, air velocity, globe temperature, and passenger count were taken at Athens. The conclusion of this paper is that the average relative humidity of platform is 5% and 11% higher than the outdoor relative humidity during the daytime at the station with a small and great depth. Paper number 10. A breakdown of energy consumption in an underground station. The author of this paper is Mikhail Kaskas, and the paper type is experimental, and it is published in the year 2014. This paper investigates the electricity consumption of an underground metro station using the data from on-site surveys and measurement. The conclusion of this paper is that the annual energy consumption of the underground station is 6,11,572 kilowatt, and the lighting system has the highest electricity consumption, and after which the refrigeration system covers the rest. Here are the references. Thank you.
Greetings everyone, I'm Anshal Arif. I'm here to begin the presentation. In this presentation, we reviewed 10 research papers on comparison of power consumption in car air conditioner and analyzed various factors affecting power consumption. Air conditioning system is a part of the power system of the vehicle, and its purpose is to provide complete thermal comfort for its occupant. However, it requires far more energy than any other car accessories, which increases the fuel consumption of the vehicle. So let's begin with the research papers. The objective of the first research paper is influence of automotive air conditioning load on fuel economy of IC engine vehicles. In this, various factors affecting air conditioning load of the engine were discussed, such as climatic condition, cabin condition, compressor speed, overall efficiency of air conditioning system, etc. The study concluded that current air conditioning system reduces the fuel economy of the conventional vehicle by at least 1.52 km per liter. And air conditioning system also causes extra CO2 emissions and thus fuel consumption increases significantly with temperature and solar radiation. Now let's continue with the next research paper. The objective is comparative analysis of the automotive air conditioning system operating with CO2 and R134A. It is a simulation-based work. The analysis shows that CO2 had an inferior COP to R134A and thus higher power consumption. Concluded that CO2-based car AC system had higher compressor power consumption than R134A-based system. Now I would like Utkarsh to continue with the next research papers. This is all from my side. Thank you.
Thank you, Larib. Hello everyone, I am Utkarsh Sharma. So let us continue with the presentation. The objective of the next research paper is reducing mobile air conditioners power consumption using active cabin air recirculation in a plug-in hybrid electric vehicle. The study examined effects of 3 different cabin air ventilation settings on mobile air conditioner power consumption, such as ACF, fresh mode with air conditioner on, ACO, fresh mode with air conditioner off, ACR, air recirculation mode with AC on. The vehicle used for study was a 2012 Toyota Prius, and this was an experiment-based study. Experimental results showed that fresh mode with the air conditioner on consumed most amount of power, followed by fresh mode with AC off, and the air recirculation mode with air conditioner on consumed the least amount of power. The next research paper is titled as an experimental analysis of automotive air conditioning systems. In this paper, an automotive AC was studied in detail and experimented, mainly the compressor power consumption. This was an experiment-based study. It was concluded in the study that when the condenser temperature increases, compressor power consumption increases. Also, when the evaporator air inlet temperature and ambient temperature increases, compressor power consumption increases. The next paper is titled as Impact of Air Conditioning System and the Power consumption of electric vehicle powered by lithium-ion battery. The basic goal of this paper is to simulate the air conditioning system impact on power energy source of an electric system. This is a modeling and simulation based work, and simulations were carried out in MATLAB Simulink. The studies concluded that the AC system influences the power consumption of the vehicle and presented a comparison of power consumption in a non-AC vehicle and an AC vehicle. So I would like to call Ankit to carry on with the presentation. Thank you.
Thank you, Utkarsh. Thank you so much. Hello, everyone. I am Ankit Yadav, and the objective of our next research paper is that impact of the electric compressor for automotive air conditioning system on fuel consumption and performance analysis. In this research paper, the study was conducted experimentally to analyze the difference of fuel uses and air conditioning performance between conventional compressor and electric compressor of the air conditioning system in automobile. Next, the result of this research paper was the electric compressor consumes less fuel compared to conventional compressor, up to 18%, and this research paper concludes the compressor performance of electrically driven compressor is higher than the belt driven compressor by about 15 to 54%. The objective of our next research paper is fuel used for vehicle air conditioning, a state by state thermal comfort based approach. In this paper, the study attempts to answer the question of the amount of fuel that a car air conditioner actually uses. This was a simulation based study. And this research paper concludes that the US uses 7.1 billion gallons or 27 billion liters of gasoline every year for air conditioning vehicles, which is equivalent to 6% of domestic petroleum consumption or 10% of US imported crude oil. And the objective of our next research paper is energy saving measures for automotive air conditioning systems in the tropics. In this paper, 3 energy savings measures are discussed. And the conclusion of this research paper was that by increasing the indoor set temperature from 20 degrees Celsius to 24 degrees Celsius, the compressor power requirement can be reduced up to 22%. This is the first method. And the smaller temperature lift can reduce the compressor power requirement by more than 30%. This is the second method. And if the dehumidification system is combined with a higher indoor temperature setting of 24 degrees Celsius, the compressor power requirement can be reduced by up to 60%. This is the third method. Now I would like to request Irfan to please continue with the presentation. Thank you so much.
Thank you, Ankit. Now we will move on next research paper. Object of the next research paper: impact of the vehicle air conditioning on fuel economy, tailpipe emissions, and electric vehicle range. In this, impact of vehicle AC on power consumption of electric vehicle, which can reduce the vehicle range. Air conditioning system is the single largest auxiliary load of a vehicle by nearly an order of magnitude. For high fuel economy vehicle, current air conditioning system have a completely unacceptable impact of fuel economy. Next research paper: reducing energy consumption on vehicle air conditioning system by an energy management system. Review. This paper presents an energy management system to reduce the energy consumption of a vehicle when its air conditioning system is in use. This is a simulation-based work. The contribution of the work include controlling mass flow rate of air by adjusting the operation speed of the blower, or automatically adjust the opening of the fresh air as well as recirculation air gets in order to maximize indoor air quality of the carbon of the cabin room. Controlling the operation of the of the evaporator using the intelligence algorithm, the results in the reduction of the vehicle energy consumption. Future scope. More work can be done using different type of refrigerants which follow Montreal protocol to often reduce the compression power consumption and hence less fuel uses. The use of solar energy powerful air conditioners can reduce fossil fuel uses. Many more energy management techniques can be devised which reduce power consumption. Thank you everyone. Thank you so much.
Hello everyone, my name is Mohammad Rashid and I am a student of 6th semester BTech Mechanical Engineering Jamia Millia Islamia University. I together with our friends Ghulam Haider and Samim Ahmad going to start a presentation on the topic solar load parameters in heat gain calculation under the guidance of Professor Aman Karimi. Let's start with a brief introduction. The heat from solar radiation is received by building surfaces in two forms, that is direct radiation and sky or diffuse radiation. The direct radiation is the impingement of sun's rays upon the surface. The sky or diffuse radiation is received from moisture and dust particles in atmosphere which absorbs part of the energy of the sun's rays, thereby becoming heated to temperature above that of air. The sky radiation is received by surfaces which do not face the sun. Now I will talk about the amounts of heat that flows towards the interior of walls due to solar radiation, which depend upon the flowing factors. First one is the altitude angle of the sun, clearness of the sky, position to the surface with respect to the directions of the sun's rays, absorptibility of the surface, ratio of the overall coefficient of heat transfer of the wall to the coefficient of heat transfer of the outside air fan. And the last one is the temperature of the ground and surrounding objects with which the heated surface may interchange radiant heat. There are few empirical methods to evaluate heat transfer through walls. There are two approaches to empirical calculation of heat transfer through walls and roofs. They are: first one is the decrement factor and time lag method. Second one is the equivalent temperature differential method. Now using decrement factor and time lag, if the thermal capacity of the wall is ignored, then the instantaneous rate of heat transfer through the wall at any time t is given by Q equals to UA TE minus TI, where U equals to overall heat transfer coefficient, A equals to area, TE equals to solar air temperature, and TI equals to inside temperature. The other method is equivalent temperature differential method. The heat transfer through walls can also be expressed in terms of an equivalent temperature difference, where Q equals to UACLT. Here Q equals to overall heat transfer, U equals to heat transfer coefficient, T1 equals to outdoor temperature in degrees Fahrenheit, T2 equals to indoor temperature in degrees Fahrenheit, and A equals to area. From here, my friend Samim Ahmad will continue this presentation.
Thank you, Rashid. Hello, everyone. My name is Samim Ahmad, and I am going to discuss some research paper on our topic solar load parameters in heat gain calculation. First, solar heat gain factor and heat loss coefficient for passive heating concept. This research paper was issued by M.S. Bhandari and N.K. Bansal. The concept of solar heat gain factor has been introduced for calculating the net energy gain of passive heating element and other components of a building as a result of incident solar radiation. For passive heating concept, namely the direct gain, mass gain, wall, outer wall, from wall, and solarium. Exact analytical expression have been obtained for the solar heat gain factor and the corresponding overall heat loss coefficient. This will allow building designer to calculate immediately the overall heat gain or loss in the building. Next, solar radiation and cooling load calculation for radiant system, definition and evolution of direct solar load. This was issued by S. Cosson, S. C. Cornetti, M. Philippi, B. W. Olsen. In this research paper, the removal of solar heat gain by radiant cooling system is investigated. Particular attention is given to the portion of the solar radiation converted to cooling load without taking part in thermal absorption phenomena due to thermal mass of the room. This specific component of the cooling load is defined as a direct solar load. Next slide. Effect of quadratic proportion on solar heat gain and energy requirement in temperate climate of Rome. This research was issued by A.S. Merton and M.B. Gadi. In this research paper, the present study focused mainly on the effect of solar heat gain on the energy demand of courtyard buildings from the different purposes. Several methods can be employed to improve the building utilization of the solar heating gain. This includes using light colors for external surfaces to reduce solar radiation absorption in the summer, using shading devices to improve the thermal properties of external wall and the roof. However, it is of great importance before using this method to have courtyard building architectural design adapt to have the full advantage of the available solar heat gain. Thank you. That's all from my side. Next part will be explained by Ghulam Haider. Thank you.
Hello everyone. My name is Ghulam Haider, BTech Mechanical Engineering, 3rd year, Jamia Millia Islamia, New Delhi. As my friend Rashid and Samim explained the topic very well, now I am continuing this topic with the paper of solar heat gain factors and the implication of building design in the subtropical region. That is published by JSLM and CL Tesson and EKM. In subtropical Hong Kong, especially Hong Kong, solar heat gain from the fenestration, particularly on vertical surfaces, plays a major role in determination of thermal performance of a building. For sizing air-conditioned equipment, maximum solar heat gain factors, that is a SHGF, are used for estimate the design peak load. Recently, the SHGF data represent the previous weather condition have become important and more practical for evaluating daylight design and determination overall thermal transfer value. Here we can see the hourly determination of SHGF. The SHGF of hourly is that is HH is bracket tau B plus Ni alpha B bracket of plus DH tau D plus Ni into alpha D, where the tau B is a transmission of the reference Gaussian for direct beam radiation, and Ni is an inert forward flowing fraction of the absorbed radiation, and alpha B is the absorption of the reference Gaussian for the direct beam radiation, and tau D transmit of the reference Gaussian for the diffusion radiation. Now we move on the next paper, that is the heat gain from thumb wall using solar energy in the cold region of Earth. That is published by Samia Karpal. In this, heat gain from the solar energy from the thumb wall was investigated in the heat that the wall materials, reinforced concrete, brick, autoclave aerated concrete were taken into consideration with the various surface colors. The passive heating potential of a thumb wall was estimated by using utilizability method, which is used to design of passive systems for heat gain. The result came into, that is, thumb wall was found to be between 26.29% for concrete, 20.5 to 7.1% for brick, and 13.0 to 4.1% for aerated concrete in different surface colors. Now we move on the conclusion of our paper. The study of an influence of solar radiation on the built environment is a basic issue in a building physics and currently. It is extremely important because the glass walls are widely used in contemporary architecture, so which create a lot of heat inside the building. Here we can see the picture clarified for more clarification. Here all are references which you use to make our presentation. Thank you so much for listening carefully. Thank you.
Start. Hi everyone, this is Momin Abdurrahman. I am BTech Mechanical third year student and I am here to begin the presentation. In this presentation, we reviewed 10 research paper on solar powered air conditioning system design. Solar air conditioning refers to any air conditioning system that uses solar power. This can be done through passive solar design, solar thermal energy conversion, and photovoltaic conversion. Next slide. First paper is design and simulation of a novel solar air conditioning system coupled with solar chimney. It was published by Fawz Ansari, Faisal Qureshi, Rashid Kiri, Chowki Ali in July 2018. This was a theoretical work which proposes a sustainable and original design for an air conditioning system with absorption, chilling, and decision humidification. The proposed design was renewable and clean energy and permits to ensure an efficient and low carbon emission air conditioning in residential and office buildings. The new design is based on coupling between solar chimney and air conditioning system. The next one is the performance advancement of solar air conditioning through integrated system design for building. This was published by K.F. Fong and C. Kelly on 14 August 2014. In this study, 3 integration strategies have been generated for solar cooling, namely integrated absorption air conditioning, integrated absorption design air conditioning, and integrated absorption design air conditioning for radiant cooling. To realize these ideas, the working pair of ammonia water was used in absorption cycle rather than H2O LIPR. Consequently, carbon reduction of building air conditioning can be achieved more effectively through the integral system design in the hot and humid cities. And the third one is the performance analysis of solar air conditioning system based on the independent developed solar parabolic trough collector published by Yong by Lifelink Coin, Jamming Gu Hoing Gainli Gaolizing on April 2020. In this paper, an independent developed solar parabolic trough collector PTC for solar air conditioning has been adopted in a solar air conditioning system with a 3-phase accumulator, and dynamic performance of the solar air conditioning system with an independent developed PTC is analyzed. The calculation analysis result shows that the solar air conditioning system with a 3-phase accumulator can continuously and steadily supply cooling for buildings day and night. This is not only improve the efficiency of the parabolic trough collector but also ensures the high energy storage efficiency of the 3-phase accumulator. Based on the economic analysis, the investment of the solar air conditioning system with a 3-phase accumulator is acceptable. The next one is the physiologic controller implementation of a solar air conditioning system published by J. and Lawrence, PP and Botsaris, VK Kodoginis on December 2007. The implementation of variable structure physiological control for solar power air conditioning system and its advantages are investigated in this paper. 2 DC motors are used to drive the generator pump and the feed pump of solar air conditioner. The different control scheme for the DC motor relational speed adjustment are implemented and tested. The second scheme is a 2-level controller. The lower level is conventional PID controller and the higher level is a fuzzy controller acting over the parameters of the low-level controller. Step response of the 2 control loops are presented as experimental result. The contribution of this design is that in control system, the fuzzy logic is implemented through software in common inexpensive Solabit microcontroller which does not have special abilities for fuzzy controller. Next to Eurofile.
Thanks, Momin Mohammed. The next paper is simulation of a solar absorption air conditioning system. It was published by ZF LIK, Simethi on February 2001. The paper presents the simulation of a solar power absorption air conditioning system with the absorption pair of lithium bromide and water. An attempt is made to increase the COP of the system by partitioning a single storage tank into 2 parts. In the morning when the sunshine is low, the upper part is activated, and in the afternoon, the whole upper and the lower tank to the collector. The analysis indicates that it is preferable to utilize a partition water tank rather than the normal stratified water tank because the cooling effect can be realized much earlier compared to the normal satisfied water tank. Also, the overall cooling efficiency, that's the cooling load to the total solar energy ratio, was found to be higher for the partitioned storage air conditioning system. And the next paper is solar power air conditioning system. It was published by Adri P. Ibrahim and Fitra on 15th August 2013. This paper proposes the concept of the system consists of an air conditioner and a PV system. In order to achieve the space cooling, the system design needs to consider both air conditioner and the PV system. There are several characteristics that are needed to know either on the PV system or air conditioning system. Electric equivalent IV characteristic and factors affect the output of PV cell is an important characteristic in photovoltaic. As far as the air conditioning cooling capacity must be determined first, as it will give a rough idea on how to design and construct the system with enough electricals and energy supplied to it. The paper considers these factors to improve the stability and efficiency of the system for greener solutions to the world's energy needs. The next paper is Design and Performance of a Solar-Powered Air Conditioning System in a Green Building. It was published by XQI on 5th of May 2008. The study is related to the solar power absorption air conditioning system, which was designed and installed in the green building of Shanghai Research Institute of Building Science. The system contained 150 square meter solar collectors and 2 adsorption chillers with nominal refrigerant capacity of 8.5 kilowatt. The operation performance of the system under representative working conditions showed that the average refrigeration output of the solar powered air conditioning system was 15.3 kilowatt during an 8-hour operation, and the maximum value exceeded 20 kilowatt. The study deduced that the solar radiant intensity had a more distinct influence on the performance of a solar powered air conditioning system. Next.
Hello, I am Faisal
From
Khan.
here, my friend Faisal will continue. Faisal.
Okay, I am Faisal Khan, student of BTech Mechanical Engineering third year. So I am starting research paper 8, Design of Direct Solar PV Driven Air Conditioner, published by Bin Jun Huang in April 2016. Design of air conditioner directly driven by standalone solar PV studies. 6 solar air conditioners were tested. The design parameter is the key. The paper concluded that for low power loss risk, solar PV module installed must be at least 3 times at load power. So next view paper is a review on solar air conditioning system design, published by Ravi Guloti in 2015. One of the greatest challenge facing mankind in the 21st century is energy. Fossil fuels such as coal and natural gas have been main energy sources for everything vital for human society. The burning of fossil fuel has caused and is causing damage to the environment of Earth. By 2015, the demand for energy could double or even triple as the global population grows and developing countries expand their economics. This has already raised concern over potential supply difficulties, depletion of energy sources, and expediting environmental impacts like ozone layer depletion, global warming, and climate change, etc. Unlike conventional air conditioning system, the decent air conditioning system can be driven by low-grade heat sources such as solar energy, air, and industrial waste heat. In this study, a focus is made on reduction in air conditioning capacity, fuel saving, and emission reduction are enabled through the use of solar energy. Now, the next paper is Theoretical Modeling of a Solar Air Conditioning System for Domestic Applications, published by P.T. Slingris in July 1993. The work described the development of a theoretical microcomputer model suitable for performance predictions and investigation of the operational behavior of a simple solar cooling system for a small residential application. The paper concluded that even at the present cost of fossil fuel, electrical energy, and mechanical components, solar air conditioning is an economical marginal application when not combined with solar heating. So I am concluding whole topic, the future of solar cooling. The increasing demand for refrigeration and air conditioning has led to dramatical increase in peak electricity demand in many countries. With the increase in demand, it comes the increase in the cost of electricity and summer brownout, which have been attributed to the large number of conventional air conditioning systems running on electricity. As the number of traditional vapor compressing cooling machine grows, so too greenhouse gas emission both from direct leakage of high GWP refrigerant such as HFCs and from indirect emission related to fossil fuel cooling heat contributes to creating the cooling demand, the solar energy. The distinct advantage of cooling based on solar energy is the high coincidence of solar irradiation and cooling demand. The use of air conditioning is the highest when sunlight is abundantly available. This coincidence reduces the need for energy storage as the cooling produced from solar energy is almost immediately used, while many professionals such as architects and installers think of photovoltaic system in combination with conventional vapor compression cooling machine as the most obvious solar option. The alternative option, solar thermal system in combination with thermally driven sorption chiller, are now a market ready technology. Thank you.
On the topic of VAV and VRF system of air conditioning. This is presented by Group 19. The group members are myself, Mohammad Abdul Rahman, Muhammad Haider Ali, Sheikh Ashad Hassan. We have done this presentation under the supervision of Professor M.N. Karemi sir. Next slide. These are the contents of our presentation. Next slide. First of all, we discuss about the VAV system. VAV, variable air valve system, work by varying the airflow in a building at a constant temperature, which is opposite working of a CAV system that varies the temperature at a constant airflow. Next slide. For larger commercial building, whether it be a 5-story office building or a shopping mall, this is pronounced advantage as it allows better temperature control. With building of these sizes, individual control is a necessity and accomplished via a main VAV airbox, zones, ductwork, and dampers. Next slide. Let us move on the next topic, VRF system. VRF is a technology that alternates the refrigerant volume in a system to match a building's precise requirements. Only a minimum amount of energy is required for a system to maintain set temperatures and ensure that it automatically shuts off when no occupants are detected in a room. Next slide. This unique mechanism achieves more sustainability in the long run as end users save on energy cost while reducing their system's carbon emission. With up to 64 indoor units connected to one outdoor unit, the VRF system operates similar to a multi-split system. Each individual indoor unit determines the capacity it needs based on the current indoor temperature and requested temperature from the remote control. Let us move on to the next topic, the difference between VAV and VRF. VRF, variable refrigerant flow, is a more recent HVAC technology that VAV and uses refrigerant as its medium to heat and cool. Whether it be a separate office or conference room or an independent store, a VRF system allows each area or zone unique temperature control without affecting the rest of the building. A few of the top advantages for VRFs for you are consistent temperature control per zone, high efficiency, installation flexibility as it pertains to smaller spaces, delivery of simultaneous heating and cooling within the building, and fewer breakdowns. I would like to invite Sheikh Ashad Hassan to continue the further presentation.
Assalamualaikum everyone. Myself Sheikh Ashad, 19BME061. I'm here to continue the presentation how a VAV system works. What distinguishes a variable air volume system from other types of air delivery system is the use of variable air volume box in the ductwork. In a VAV system, AHU cools to heats air to accommodate the zone with the most extreme requirement, supplying the air through the ducts to various zones. As the load decreases in one particular zone, the VAV air valve throttles the airflow, matching the space requirement. Next slide. Next slide. VAV system benefits. First is efficiency. VAV systems are low on energy consumption. During the lean periods, the AHU fan can run at slower speed and the amount of heating and cooling mediums running through the coil can be reduced. A VAV system allows the AHU, chillers and boilers to run a part load majority of time. Next slide. Second is individual temperature control. VAV system provides optimum control of temperature, especially in the areas with wide load variation. Third is humidity control. Humidity refers to moisture content in the air. It must be controlled in conjunction with air temperature to provide a comfortable environment. Next slide. Fourth is cost. VAV systems are sized for diversified block load rather than a sum of zone peak loads. Fifth one is flexibility. A VAV system is capable of serving multiple zones with varying load demands. Next slide. The disadvantages are VAV zone requires a terminal unit. Terminal unit must be in easily accessible location for its particular zone. Terminal units will require periodic maintenance in addition to usual attention paid to the central unit. Next slide. Design challenges. Inadequate ventilation. First is providing proper ventilation with simple VAV system present a challenge. Second is control problems. How to sense small changes in static pressure, how to balance return air system, and how to maintain constant flow of outside air with variation in supply and return air flows. Next slide. Third is poor air distribution. As VAV system reaches its design set point, the volume of air delivered to a room is decreased. This affects the air distribution. Fourth one is VAV box location. Since VAV box must be located in the branch ductwork, they are often placed above the ceiling. Now I will call Mohammed Haider Ali to continue the presentation.
Thank you, Sheikh Asad. Hello everyone. I will discuss about VRF system and its advantage. The main advantage of a variable refrigerant flow system is its ability to respond individually to fluctuation in space load conditions. VRF system enable wide capacity modulation, bring room to desired temperature extremely quickly and keep temperature fluctuation to minimum. VRF systems can generate separate billing that makes individualized billing easier. VRF systems are capable of simultaneous cooling and heating. Each individual indoor unit can be controlled by a programmable thermostat. The technology offers excellent dehumidification performance of optimal room humidity regardless of outside conditions. Any area in the building will always be exactly at the right temperature and humidity, ensuring total comfort for their occupants. Now we will discuss VRF challenge and limitation. First, refrigerant piping. A VRF system being a split installation is restricted by the distance criteria between the condensing unit and the evaporator. All split systems therefore have a maximum allowable vertical and total refrigeration pipe wall length. It's important that a design owner is aware of this limitation. Second, compliance with NC S-Ray Standard 15-2001. VRF system must comply with S-Ray Standard 50-2011 safety standard for refrigeration system. Third, reliability and maintenance. Although suppliers claim that VRF system and very reliable, contractor and engineers believe that VRF system with many compressors is inherently less reliable than a chiller, which has a smaller number of compressors. For environmental concern, ozone depletion issue have become a global concern and the issue of a high refrigerant charge associated with long refrigerant lines of the RF system is a strong negative for the system. Fifth, VRF systems are proprietary systems. VRF systems are complete proprietary systems from the controls to the condensing unit. These are some conclusions. The first one, the advantage of VAV system over constant volume system include more precise temperature control. Second one, VRF provides an alternative realistic choice to traditional central system. Third one, VRF technology is based on the simple vapor compression cycle, but the system capabilities and limitations must be fully understood. Fourth one, before working with VRF system, it is strongly recommended that manufacturers' products training be undertaken. These are some references from which we can get a lot of information about VRF system and VAV system. Thank you.
Hello everyone, this is Mohammed Zafar from Jamia Millia Islamia BTech Mechanical 3rd year. I, the member of Group 20, I and Mohammed Azzad Mohammed Ghazi are going to give a presentation on substitute refrigerants of R11, R12 and R22 under the supervision of Professor M.N. Karimi. Next slide. In early 1980s, scientists discovered some CFCs which are used in ACs and refrigerators, but due to high ODP of R11, R12 and R22 under Montreal Protocol, the uses of these refrigerants are prohibited, and substitutes of those refrigerants are introduced, but the ODP of those substitutes are also not completely zero. Hence, next slide.
Now the substitute of R11 as a Montreal Protocol meeting in 1985, R11 is suddenly phased out from the market, and instead of and R123 is introduced in place of R11, which is compatible with the R11 appliances. Next slide. As substitute of R12, as 191 countries are signing the petition under the Montreal Conference in 1985. R12 is also phased out from the market later on, and the substitute of them are introduced like R134A, R401A and R401B, which are compatible with the system of R12 and also used for refrigerators and air conditioners. Next slide. R22 is being has phased from January 1, 2010, and the substitutes of R22 are R134A, R507, R404A, R407, R410A, whereas R507 is a combination of R125 and R134A, and R407C is a mixture of R125, R32 and R34A. R410A is used for air conditioner, and R404A and R507 is used for refrigerator. Now from here Muhammad Azhar will continue the slide.
Hello everyone, myself Muhammad Asjad from Jamia Millia Islamia BTech Mechanical Engineering 6th semester. Here I am on the behalf of a group member of 20. We will first look at the review of different ages of regarding the substitute of refrigerants of R11, R12 and R22. Now we will start the review of different research papers. The use of natural refrigerants in the refrigeration and air conditioning system. It was a theoretical type research paper. After the signing of the Montreal Protocol, several steps were taken in the refrigerant system. These steps were regarding to the improvements in the minimization of ozone depletion layer and global warming potential. Several types of refrigerants were banned, and many new substitutes were introduced like R410A and R417A. Next slide. Options and outlook for chiller refrigerant. It was also a theoretical type of research paper. For the chiller refrigerant, many new types of refrigerants were introduced after banning the CFC, HCFC, and HFC on the basis of their efficiency, toxicity, and flammability. Next slide. The paper examines future refrigerant options for chiller. It was also a theoretical type of research paper. After signing the Montreal Protocol, CFC, HCFC, and HFC were completely banned, and for the place of these refrigerants, some refrigerants were introduced for the short period of time, such as R11 and R12, which were further completely banned. And final solution were overcome as a R134A. Next slide. The use of natural refrigerants in the refrigeration and air conditioning system. After banning of these refrigerants, there were also many possibilities of introducing the natural refrigerants, such as CO2, NH3, and of the many hydrocarbons and their derivatives. Next slide. Environment-friendly alternatives to halogenated refrigerant. It was also a theoretical type of research paper. At the time of Montreal Protocol, the developing countries widely used the hazardous and halogenated refrigerants. But after signing it, it was mandatory to those countries to completely ban or phasing out the consumption and production of these types of refrigerant. And at the place of these refrigerant, to introduce many types of hydrocarbons, hydrofluorocarbons, and their mixtures as a refrigerant for the suitable alternatives. Next slide. assessment of LPG as a possible alternative to R12 in domestic refrigerators. It was also a theoretical type of research paper. After many examination and experimental approach, it was found that LPG is also used as the place of R12 as a refrigerant. A mass charge of 80 gram have a better performance when used in the refrigerator at the place of R12. That was all from the my portion. Now Gaji will continue the presentation.
Thank you, Ajay. I am Mohammad Ghazi, BTech 6th semester student, Mechanical Engineering. Now I am continuing from this research paper, Comparative Efficiencies and Implementation for the Greenhouse Gases Emissions of Chiller Refrigerants. The review of the paper discusses briefly the historic progression in the refrigerant release, reduction and presentation analysis. Improvement made in the refrigerant to minimize the depletion of ozone layer was observed increasing day by day. Now move to next slide to give a review of the possible this possible substitute for fully hydrochlorofluorocarbons using pollute already market. As we know that in 191 countries taking oath for saving the ozone layer for by signing of the Montreal Protocol in 1987, and the refrigerants like 134A and 123 are used as a substitute for in place of R11 and R22. Now I move to next slide for the review of research paper, Solar Assistant Vapor Compression Absorption Cascading Air Conditioning System. In this, the condenser of the R22 system is cooled by the evaporator of the ammonia system, and this facilitated operation of the R22 system at a low condensing temperature and pressure. Now I move to next slide to give our review of our research paper overview of alternative to CFCs for domestic refrigerator and freezers. In this research paper, as we know that most of the domestic refrigerator and freezers are CFCs 11S blowing agent, and nowadays I'd like refrigerant like R134A R401 are replace the refrigerant like CFC 11 and CFC 12 because this refrigerant emits chlorine and its derivative in the atmosphere, which ultimately harm the ozone layer. Now I move to the conclusions. As we know, improvement made in the refrigerant to minimize the depletion of ozone layer was observed increasing day by day. And keeping this in mind, CFC, HFCs, refrigeration and its derivatives are worldwide prohibited due to the Montreal Protocol. And in place of this, the R34A, R22 refrigerant like use efficient enough and eco-friendly too. So nowadays this refrigerants R34A and R401A, these are the refrigerants which obey the Montreal Protocol and step toward the sustainable development and help to minimize the depletion of ozone layer day by day, obey the rules of Montreal Protocol and lead to the environmental betterment and help the reduction of global warming. Now move to the these are the from where we are taking the research paper. Our content of this. Now these are the references, and lastly, thanks to all of you. Keep listen our PPT patiently. So anyone have any question regarding this PPT, please comment in comment section.
Hello everyone. First of all, let me thank Professor M.N. Karimi for giving us this opportunity. We are group 21. I am Anu Raghav. I have Mohammad Salman Shams and Mohammad Adil Raza with me. As you can see on the screen, our topic today is fourth generation refrigerant analysis. So before diving deep into the topic, first let's discuss what a refrigerant is. A compound typically found in fluid or gaseous state. It readily absorbs heat from the environment and can provide refrigeration and air conditioning when combined with other components such as compressor and evaporators. Some most common refrigerants used for air conditioning are R12, R22, R410A, R134, etc. Refrigerants can be classified as halocarbon based and non-halocarbon based, primary and secondary, pure and blended, as shown on the figure. Now let's discuss about different generation of refrigerants. So first generation of refrigerants started early in 19th century, which is characterized by use of natural refrigerants such as air, water, later methyl chloride and ammonia were made. Nearly all first generation refrigerants were flammable, toxic and highly reactive. Then came second generation of refrigerants, which were distinguished by a shift to chlorofluorochemicals for safety and durability. Later scientists learned that CFC isn't harmless as it is depleting stratospheric ozone. After which Montreal Protocol was ratified by 196 nations, and Jan 2010 marked the end of global production of CFC. refrigerants, hydrofluorocarbons, and HFCs have been developed to replace second-generation refrigerants. They had low ozone depleting potential, but later the harmful impact of fluorine on global warming was fully understood. When HFCs were listed as greenhouse gases by Kyoto Protocol, low GWP was desired and fourth-generation refrigerants came into the picture. Now, moving on to the reviews of research papers done by our group. The first paper, Thermodynamic Analysis and Effects of Replacing HFC by fourth-generation refrigerants in VCR system, which was published in the year 2018 by the author Mr. Sachin Gupta. In this analytical research paper, the performance of fourth-generation refrigerants in terms of their mass flow rate requirement and COP for a specified cooling load was compared with the existing third-generation refrigerants. The next paper by James and Calm, in this paper the progression of refrigerants from early use to present and future direction were discussed. Also, paper examined the outlook of current options in the context of existing international agreements. This next paper by Wellefort, published in the year 2017, objectifies to predict the vapor-liquid equilibrium, isobaric heat capacity, speed of sound, and surface tension of selected HFC and HFO-based chemical heterotrophic blends as fourth-generation low refrigerants. Up next is Mohammad Salman Shams, who will give us review on further papers. Thank you.
Thank you, Anu. Now from the fourth paper, which is given by Pushinat Shenge, development of environmental friendly and energy efficient refrigerant from the medium temperature refrigeration system. This research paper given in 2020 based on some software such as Cycle DHX DK Nuggets. The results of the refrigerant mixed by the R134A, R32, R125 and R1270 is consist with the evolution of 4th-gen refrigerant that consists of a mixture of HFCs and HCs which are required to produce low GWP, zero ODP, high capacity, low operating pressure and non-toxic refrigerants. For the next paper, which is fifth one, which is given by the Rabia 2, energy analysis of vapor compression refrigerant cycle using a new generation refrigerant with low global warming potential. This research paper is published at 2021. Vapor compression refrigerant cycle concepts is used in this work. The result shows that the HFO R1234ZE with low GWP gives the best coefficient of performance such as 3.14 closing to the R134A, which is 3.17. In the addition of R1234ZE is consist an alternate fluid to R134A for these ecological properties. For the sixth paper, which is given by our Jamia Millia Islamia teachers such as Vipin Kumar sir and KM Karimi sir. Mathematical simulation of 4th gen refrigerant R1243ZF is single stage and double vapor compression refrigeration system. In the same minimum and maximum pressure limits, the effects of vapor temperature and condenser temperature has been seen on COP for both the system, and results shown that which decrease in evaporator temperature COP is decreased, whereas decrease in condenser temperature COP is increased. For the seventh paper of research, first observation for the 4th generation synthetic halocarbon HFC 1234YF 1234ZE 1233ZD in the atmosphere by the analysis and measurement of these particular refrigerants. As a result, based on a simple one box model calculation with estimate global increase HCFC 1233ZD emission from 0.2 to 0.5 in one single year. Now I would like to call Adil Raza for the further presentation.
Thank you, Mr. Salman, for handing over the presentation to me. As introduced by Anu earlier, my name is Muhammad Adil Raza. Straight away diving into the topic, I would like to review the 8th research paper, the topic being investigation and analysis of R463A as an alternative refrigerant to R404A with lower GWP. This research paper was published in the year 2020 by Pianat Sengescu. It was analytical research using database software like RefProp and CycleTHX. The primary objective was to investigate and analyze R463A as an alternative to R404A. The drawn output of this research was R463A has 52% lower GWP than R404A and 10% higher COP. Hence, it can replace R404A. Moving on to the next research paper. Which was published on January the 2nd, 2019 by Gabriel Rabe, based on comparative energy and exergy analysis of a subcritical cascade refrigeration system using low GWP potential refrigerants. It was a simulation study research paper that covers the study of vapor-liquid equilibria of different binary mixtures of working fluids and refrigerants, particularly HFO1123. The research concludes that HFO1123 has an extremely low impact on the low environment. Its ODP is 0 and its GWP reaches up to merely 0.3. HFO1123 is therefore a possible substitute to R32 and R410A. And finally, moving on to the 10th research paper based on molecular simulation studies on refrigerants. It was an experiment-based research by Senker and Timmer in 2020 in which low GWP refrigerants were studied in cascade refrigeration systems. The primary objective was to suggest a potential substitute to refrigerant R423A and to study the impact of various operating parameters on system performance. From research, the following outputs were drawn. R41 RP170 performs better in CRS at low temperatures. R41 R423 protocol are unstable molecules with low global warming potential in addition to the zero ODP. The fourth generation refrigerants are unsaturated hydrofluoroolefins having low atmospheric life due to the presence of double bonds. The two main HFOs are HFO1234ZE and HFO1234YF, which are sold under the brand names of Opteon YF and Solstice YF. But the problem with the HFOs is that in some cases, the efficiency and COP are being compromised. The new generation must offer higher efficiency or the change to address low GWP will backfire. This is our challenge going ahead. A refrigerant having very low GWP, zero ODP and desirably high COP is yet to be discovered and the research continues. Thank you. This is all from our side.
हेलो बीच में लाइन कट गया था यार आदिल के टाइम पे बट मेरे साथ ज़्यादा नहीं कटा हल्का सा ही कटा क्या करना
हो गया भाई कोई बात नहीं हो गया
A very warm welcome to all of you present here today. We, the group members of Group 22, including Fahad Musawwir, Mohammad Yasir and myself, Abdurrahman Ansari, are going to give you a presentation on the topic flash gas and flash intercooling. For this, we would like to thank our Professor Munawar Nawab Karimi sir for giving us this opportunity. First, I'll start with the introduction of flash intercooling. A flash chamber is a device which separates liquid from vapors. Only liquid is then passed to evaporator and the vapors will be passed to the compressor directly. This flash chamber between the condenser and the evaporator is known as flash intercooling. Now, in flash gas and refrigeration, the flash gas is refrigerant in gas form produced spontaneously when the condensed liquid is subjected to boiling. The presence of flash gas in the liquid lines reduces the efficiency of the refrigeration cycle. Flash gas must not be confused with the lack of condensation, but special gears such as receivers, internal heat exchangers, insulation, and refrigeration cycle optimizers may improve condensation and avoid gas in the liquid lines. Now I'm going to talk about flash gas bypass for improving the performance of transcritical R7 FOFO systems that use microchannel evaporators. The performance of transcritical R7 FOFO systems with direct expansion can be significantly improved by implementing a FGB, that is flash gas bypass. The idea behind it is to bypass refrigerant vapor created during the isenthalpic expansion process around the evaporator. By feeding the evaporator with liquid refrigerant, pressure drop is reduced and refrigerant distribution is improved. With R744 as the working fluid, increased refrigerant side heat transfer coefficients are expected as well. Now, R744 is carbon dioxide CO2. It is an environmental friendly refrigerant. Its ODP is 0 and global warming potential is 1. And the flash gas bypass, it is capable of improving the system's coefficient performance as well as the cooling capacity by increasing the refrigerant side heat transfer coefficient and by reducing the refrigerant side pressure drop on the low pressure side of the system. In addition, FGV also improves the refrigerant distribution in the evaporator inlet, leading to further in performance improvements. Now, its description is that improving the efficiency of transcritical R7 FOFO system is of utmost importance for its application. One possible approach is the implementation of a flash gas bypass. In a conventional vapor compression system with direct expansion, refrigerant under high pressure is expanded to a low pressure before it enters the evaporator. In transcritical systems using R7 FOFO, the refrigerant at the inlet to the expansion device is typically a single phase fluid with its high side pressure exceeding the critical pressure. The idea behind the flash gas bypass concept is to bypass this vapor flow around the evaporator. The concept can be implemented by using a so-called flash tank downstream of the expansion valve instead of a suction accumulator downstream of the evaporator. The FGB concept is capable of reducing the refrigerant side pressure drop on the system's low pressure side for many reasons. First of all, the refrigerant mass flow rate through the evaporator is reduced due to liquid vapor separation. In this figure, we can see the application of the flash gas bypass concept to the conventional ECU system having a two-stage conditioner with intercooling. Now, the conclusion is that the flash gas bypass concept was introduced and expected benefits were described. In addition, FGB also improves the refrigerant distribution in the evaporator inlet header, leading to further performance improvement because of the possibility to operate the system at higher evaporation pressure for a given capacity. Now I would like to call Fahad Musawwir for continuing the presentation.
Thank you, Ansari. Now we'll see the flash gas bypass method for improving performance of an AC system with a microchannel evaporator. In this, the flash gas bypass method significantly improves the performances of a microchannel evaporator and the system compared to the conventional direct expansion system. When system in both modes operated at the same compressor speed, the system in the FGB mode produces about 13 to 18% more cooling capacity at 4% to 7% higher coefficient of performance than in direct expansion mode. When compressor speed was adjusted to maintain the same cooling capacity, COP improves from 37% to 55%. Now we'll see the FGB benefits and their contribution to the performance improvement. When implementing a flash gas bypass in the mobile AC system, two benefits are observed at least for system performance. First is improving refrigerant distribution among parallel MCU, and second is reducing refrigerant side pressure drop in the evaporator. The magnitude of performance improvement due to each benefit strongly depends on the evaporator performance in the baseline DX system, such as evaporator pressure drop, the uniformity of refrigerant distribution, the relative size to the system. The second benefit is the pressure drop reduction. It is a strong function of both initial evaporator pressure drop and the inlet quality in the direct expansion system. The left figure shows the local pressure drop gradient in the microchannel in the direct expansion and FGB mode. The right figure shows the reduction of evaporator pressure drop by FGB method, strongly depending on the baseline pressure drop in the direct expansion mode and refrigerant inlet quality. Next slide. Now we'll see the type of refrigerant mile distribution in the microchannel evaporator. There are two. First is the uneven refrigerant quality at the inlet of each tube in the dividing header. Second is the additional pressure drops in the headers. The uneven quality distribution is mainly due to inherent non-homogeneity of two phase flow. Such characteristics has two aspects. First, vapor and liquid refrigerant have different densities and inertia in the mixed flow. Second, in the horizontal header, the vertical downward gravitational force intends to separate liquid and vapor phase toward the upper and the lower portion of the header and results in a stratified flow regime. Next slide, please. Now we'll see the conclusion. Flash gas bypass approach was implemented in an R134A mobile air conditioning system with a microchannel evaporator. Compared to the conventional direct expansion system, it is found that the major benefit of FGB approach is to eliminate refrigerant maldistribution caused by uneven quality supplied to each tube inlet. Second is another benefit is a reduced refrigerant pressure drop across the evaporator. Third, even the principal FGP method is universal, the magnitude of performance enhancement strongly depends on the evaporator design, quality, and size relative to the baseline system. Now, I would like to call Mohammad Yasir to continue this presentation further.
Thank you for Fahad. Now I'll talk about flash gas bypass concept utilizing low pressure refrigerants. Flash gas bypass represents one of the prospective approaches to improve the efficiency of various small scale heat transfer systems that utilize refrigerant as a working fluid. It is characterized by the bypass of vapor created throughout the expansion process around the evaporator. As the advantage of flash gas removal in R744 systems are observed, it is scientific interest to elaborate the same approach in R134A or similar low pressure refrigerant AC systems. Implementing flash gas removal techniques which dramatically reduce pressure drop can play a major role in making low pressure fluid systems more beneficial, since these fluid systems are more affected by pressure drop. Next slide, please. It is characterized by the bypass of vapor created throughout the expansion process around the evaporator. The FGB configuration has 4 degree centigrade higher evaporation temperature compared to the other configuration at the meshed cooling capacity, which reduced compressor pressure ratio, increased its isentropic efficiency, and lowered power requirement, ultimately producing higher COP of the system by 20% compared with the DX baseline configuration with 2 evaporator inlets. Next slide, please. Now the conclusions are FGB improved the low refrigerant side pressure by reducing the low refrigerant side pressure drop and improving the refrigerant distribution in the evaporator inlet header. The other effect contributing to the increase in the system efficiency need to be further analyzed. Future flash tank design should focus on improving the vapor phase separation efficiency. Even with this baseline separator, FGP system performed more efficiently at a meshed cooling capacities. This shows prospects of implementing the concept in AC systems. The presence of flash gas in the liquid lines reduces the efficiency of the refrigeration cycle. Next slide, please. Here are some of the references which we have included in our project. Next. And that's all. Thank you very much for listening.
Assalamu alaikum everyone. I am Dilshad Rabar. We, the group member of 23, are going to present the review of different 10 research paper on the cascade system design and application. And we are mentored by Karimi sir. Next slide. Description. To produce ultra low temperature, the evaporator pressure are low and hence pressure ratio will be higher. This result in decrease in volumetric efficiency. If here you can see in the equation volumetric pressure ratio increase, that's why volumetric efficiency. Hence to avoid this we use cascade refrigeration system which you can see in the figure. In cascade system, 2 or more vapor compressor cycle with different refrigerants are used. Next slide. First review on the thermodynamic analysis of transcritical CO2 propylene cascade system and cooling and refrigeration application. In this system, CO2 is used for higher temperature cycle and the propylene is used for lower critical cycle. And thermal performance of the cascade is evaluated for different combination of design, operating, variable and optimum performance parameters such as T optimum, COP maximum, and the mass flow rate of CO2 has been predicted. The result of analysis show the thermal performance of CO2 propylene transcritical cycle, then subcritical cascade cycle, and also they are better than N2O and CO2 transcritical cycle. Next slide. Second one is theoretical analysis of CO2 and S3 cascade refrigeration system for cooling application at low temperature. This application is done because of ozone depletion layer. Because use of chlorine in the refrigerant is depleting rapidly the ozone layer. That's why organic refrigerant is generated for the come over the issue of depletion of refrigeration system. Next slide. Third one is a theoretical comparative study of CO2 cascade refrigeration system. The review of this, it is done. CO2 is in this paper. CO2 is compared with different refrigerant, and they find that CO2 is worst refrigeration system, all of them, like NS3, R290, R600, R600A, and 1270. These are the most appropriate choice according to the energy and TEW criteria. Thank you everyone. I would like to hand over my presentation to Muhammad Salman. Thank you everyone.
Thank you Dilshad, and myself Muhammad Salman, continuing my presentation with Dilshad. Change slide. Analysis of cascade vapor refrigeration system with various refrigerants. In this paper, report the performance analysis of different refrigerant couples in cascade refrigeration system using R134A or R23, R410A or R23 has been successfully analyzed in superheating and subcooling range within temperature limits of 10 degrees Celsius and 5 degrees Celsius. And the variation in condenser temperature was from 30 to 50 degrees Celsius, and the low temperature varied from minus 70 to minus 50 degrees Celsius in evaporator. Compressor efficiency, which they assumed, was 0.7 throughout the experiment, and from experiment it has been revealed that there is an enhancement in COP and flow rate with rise in compressor work and evaporator temperature. And from this study, we conclude that if the refrigerant pair R134A, R170 was found to have a greater efficiency, greater COP of and lower mass flow rate, and pair 404A or R508B was found to have smaller COP and greater mass flow rate. Next slide. Next, the thermodynamic analysis of cascade refrigeration system using CO2 and H3 refrigerant for fish cold storage application. And in this study, the thermodynamic analysis of cascade refrigeration system present the use of carbon dioxide on the LTC and ammonia on the HTC. This analysis leads to the following conclusion that if an increase in the temperature of evaporator produce an increase in COP and decrease both the work requirement by the compressor and mass flow rate. An increase in condenser temperature result in decrease in COP and increase in mass flow rate and work required by the compressor on the HTC. Next slide, Dilshad. The cascade refrigeration system. This paper provides a literature review of cascade refrigeration system. Important system that it can achieve an evaporating temperature as low as up to minus 170 degrees Celsius, the refrigeration temperature range of conventional system. In this paper, several research options such as various designs of CRS, studies on refrigerant and optimization work on system are discussed. Moreover, the influence of parameters on system performance, its economic analysis and applications are defined, and gives some suggestions as well. Next slide, Dilshad. And last is the analysis of cascade refrigeration system by using different refrigerant couples based on exergetic performance coefficient EPC criterion. A theoretical performance analysis based on exergetic performance and coefficient criteria has been carried out for cascade refrigeration system for different refrigerant couples, and the EPC criteria is defined as the ratio of exergy output to the total exergy destruction rate or loss of availability. And according to the results of the study, the refrigerant couples are 23 R717 shows the best performance in terms of EPC and coefficient of performance from among the other refrigerant couples as well. Now, thank you. That's all from my side. Now, I would like to hand over my presentation to SM Ibrahim Haider, which who will further continue.
Thank you, Salman. Hello, everyone. I have reviewed three papers regarding cascade system design. The first is optimization of CO2, like carbon dioxide and propane cascade system for refrigeration and heating. In this paper, a cascade system for simultaneous heating and cooling with a carbon dioxide based high cycle and propane based low voltage cycle for simultaneous refrigeration and heating applications has been analyzed. Relevant expression have been developed to serve as guidelines to the user for selecting appropriate design parameters like intermediate temperatures so that the system yields optimum performance independently. Developed properly codes have been have been employed for both carbon dioxide and propane for high accuracy. Next slide. Next slide. And this is a novel cascade absorption, a heat transformer process using low grade waste heat and its application to coal to synthesize natural gas. This research paper is written by Sheng Yang, Yu Kiana, and this was issued on 12th April 2017. As we know that energy challenging is becoming more and more serious. A large amount of waste is discharged in chemical process industry, of which 60% can be recycled in theory. So, in this paper, absorption heat transformer is studied and novel cascade absorption transformer (NCAHT) is proposed to recover low-grade waste heat. The NCAHT is testified in a coal to synthetic natural gas plant. Results show that the total capital investment of a 12 megawatt NCAHT is 924,000 US dollars. Financial internal rate of return is used as economic evolution index. So next slide. Dilshad, next slide. Okay, now this my last paper is performance of cascade refrigeration systems using different refrigerants. This paper presents a thermodynamic analysis of different two-stage cascade refrigeration systems using as refrigerant carbon dioxide R744 in low temperature circuit and respectively ammonia R717, propane 290-butane etc. And R134A in a high temperature circuit. The operating parameter considered in this study include condensing and evaporating temperatures in a high temperature circuit. Temperature difference in the cascade heat exchanger and evaporating and condensing temperatures in the low temperature circuit. The results obtained show that a cascade refrigeration system using natural refrigerant is an interesting alternative to system using synthetic refrigerants for energetic security and environmental reasons. So this is all about my review.
So our group have reviewed 10 research papers, and these are the references from where we took our material, and that's from all our side. Thank you. Bas?
Hello, good morning everyone. So today me, Daniel Zia, and my two classmates, Rahul Goyal and Anas Tahir, will be presenting the refrigeration and air conditioning presentation based on a topic of use of enzymes and CFD in condenser design. The enzyme is an ancestor system
and CFD is the software used, that is compression and fluid dynamics. So the topic on which we are discussing on research paper is use of MTNM CFD in condenser design. We have discussed 10 research papers on which we not only explain the exact operations of the authors, but also the learnings, just scope, practical industrial applications, simulation software use, experimental techniques, formulas, tables, and etc. Next slide. Next slide. So our first research paper is CFD modeling of a thermal chimney for air-cooled condenser. Traditionally, chimneys are an aperture structure for initiating a hot air flow to discharge the smoke out of the house, composed of two elements, that is heat source and vertical source. Next slide. So the second paper is pressure drop of HFC refrigerants inside evaporator and condenser coils as defined by CFD. This is an analytical work and the formula used shows in front of your screen. Learnings. Pressure drop across a suction line reduces a system's capacity. A system's capacity is based on how much refrigeration is in pounds per hour is circulated throughout the evaporator. Next slide. So the third research paper is an investigation of the effects of geometry design on refrigerant flow, maldistribution, parallel flow, condenser using a hybrid method of finite element approach and CFD simulation. And the type of work is simulation based and the software used is BTech. Learning. This method is used to investigate tube pollution depth, inlet duplication, pressure drop across the suction line reduces system's capacity. Next slide. So now Anas Tahir will be continuing the next research papers on our topic.
Thank you. Good evening, everyone. I am Anas Tahir from Jamia Millia Islamia, BTech Mechanical Engineering 3rd semester, and the research paper is that a coupled CFD approach for performance prediction of fin and tube condenser, and this is simulation based, and the software used is Flint version 17.2, and the learning is the parametric investigation showed that the air frontal velocity had a significant effect on the air side temperature distribution as compared with the inlet temperature. There was no refrigerant cooling at the condenser outlet when the air frontal velocity was relatively low. And the next research paper is NCCFD analysis of the thermal behavior of coolant 134A in a condenser within a refrigeration cycle, and the type of work is simulation based, and the software used is FreeCAD and MATLAB, and the learning is the numerical simulation by means of CFD helps to better understand the internal behavior of the fluid as well as to interpret the phase change process and specifically the condensation and the flow regime inside the pipe correspond to a turbulent flow. And the next research paper is thermal analysis of hot wall condenser for domestic refrigerator, and the type of work is both experimental and simulation based, and the software used is ANSYS 14, and the conclusion is in the slide, and the learning is that from the analysis result of the analysis I have found out that if we increase the contact angle between tube and wall, heat flux is increased and also thermal gradient is increased. And the next research paper is numerical investigation of condensation in inclined tube air cooled condenser, and it is analytical work based, and the formula used is given in the slide. And the learning is that a stratified film condensation model is introduced for the flow in an inclined tube with convecting cooling. A film condensation model is coupled to measured air side local heat transfer coefficient distribution. And I would like to invite Rahul Goyal to continue further presentation. Thank you.
Hello everyone, I am Rahul Goyal, student of Jamia Millia Islamia studying BTech Mechanical in 6th semester. This is our 8th research paper, 3D CFD simulation of air-cooled condenser, natural convection over a circular cylinder. This is a simulation-based work and the software uses OpenFOAM 2.2. These are the learnings we can draw. The distance between the cylinder and the top wall is an important parameter. The 3D numerical simulation must be performed to capture the 3D flow phenomena in natural convection. The interaction of closer walls and cylinder can lead to a 3D oscillating and complex fluid flow. This is the 9th research paper we have studied. 3D CFD simulations of air-cooled condenser natural draft around a single fin tube kept in a small chimney. It is a simulation-based work and the software uses OpenFOAM 2.2. The learnings: the effect of chimney height has been found a combined effect of air outlet and the driving force generated by the chimney. It was observed that the elliptical tube performs better than the other circular and elliptical tubes. It is the 10th research paper, 3D CFD simulations of an air-cooled condenser, thermal hydraulic characteristics and design optimization under forced convection conditions. It is a simulation-based work and the software uses OpenFOAM 2.2. The learnings we can draw is the fin efficiency was observed to decrease with increase in the fin spacing and the number of tube rows. Number of tube rows is the most important parameter. Tube pitch affects the pumping power and compactness. Fin spacing affects the heat transfer per unit pressure drop. These are the conclusions that we could draw after our study. Thermal chimney had decadently decreasing because of pollution and global warming. The increasing trend of heat transfer rate was relatively slow with lower air inlet temperatures. From the analysis result of ANSYS, we have found that if we increase the contact angle between tube and the wall, heat flux is increased and also thermal gradient is increased. The optimization of outer unit of split AC would refer to maximize the gains by higher heat transfer. The trade-off between all the key input parameters can be seen by performing CFD analysis for various configurations. The future scope of this research could be thermal chimney are further shall be a great way in reducing the air pollution. HFC increase in uses of refrigeration, hybrid method of finite element approach CFD advanced software. Same analysis can be done with better meshing using hyper mesh kind of software. Optimum contact angle can be found out by using genetic algorithm kind of advanced method. These are the references of first 5 research papers we have studied. These are the references of other 5 research papers we have studied. So this was all from our side. You can drop down your questions in the comment box below. Thank you.
Good morning, respected teacher and my dear fellow students. Today I am Faisal Hussain and with me Mohammad Danish and Amrish Shankar. Today we all are here for our presentation of refrigeration and air conditioning. And our presentation topic is difference between cold storages and CA cold storages design and application. Next slide please. So I would like to start with the introduction. Cold storage. Cold storage is a large refrigerated room or building designed for storage of goods in an environment below the outdoor temperature. Products needing refrigeration include fruit, vegetables, seafood, and meat. Cold stores are often located near shipping ports and used for import-export of products. Cold stores have been an essential part of the shipping industry since the late 19th century. Next slide, please. Now I want to talk about CA cold storage. Controlled atmosphere CA. Storage of fruits and vegetables refers to storage in atmospheres with reduced levels of oxygen and or relatively high carbon dioxide concentration at low temperature and high relative humidity. CA cold storage, low O2 and high CO2 levels slow the ripening process, stop the development of some CA cold storage disorders such as scald in apples and slows the growth of decay organisms. All these effects increase storage life of fresh products compared with conventional refrigerated stores. These facilities are recommended for long-term storage of fruits and vegetables like apples, pears, kiwi, cabbage, etc. for up to 10 months. Next slide please. So I would like to start with our first paper, and the topic of the first paper is optimal design and application of a compound cold storage system combining seasonal ice storage and chill water storage. This paper presents a compound cold storage system that combines a heat pipe based seasonal ice storage system with a chill water storage system. In summer, the stored ice is extracted for cooling and then the melting ice is used as a chilling medium for chill water storage. A case study is conducted to demonstrate the design and application of the proposed system in a real building in Beijing. And this process is on experimental basis and its results shows that the appropriate combination of the two types of cold storage can greatly improve the applicability of the seasonal cold storage and reduce the life cycle cost of a building cooling system by 40%. Next slide please. So our paper 2 is on review of cold storage material for sub-zero application. According to the type of storage medium and the way of storage medium is used, phase change material PCM storage and sorption storage are introduced separately. Micro-encapsulated PCMs are introduced as they have an excellent heat transfer performance to the surrounding because of the large surface per volume of the capsules and the excellent cycling stability due to restricted phase separation in microscopic distances. PCMs with nanoparticle additives are also discussed as they have higher thermal conductivity for better storage process, and this paper is on experimental analysis. Next slide please. So I want to review our third paper, development of composite phase change cold storage material and its application in vaccine cold storage equipment. The aim is to develop phase change material with a phase transition temperature of 2 degree to 8 degree. In this study, a mixed solution of tetradecane and L'Oreal alcohol La was selected as the base liquid. Expanded graphite EG was added to TALA to improve the thermal conductivity. The vaccine reagent tube can be placed in the storage pool of the cold storage box. Coupling the development low temperature phase change material with the cold storage equipment can ensure that the vaccine is always in the required low temperature environment in the process of transportation for a long time to ensure its quality. And this is on experimental analysis, and this shows us how vaccine is maintained at a low temperature. Next slide, please. So our fourth paper is for e-analysis, multi-objective optimization of an ice storage system incorporating PCM as the partial cold storage for air conditioning applications. An ice energy storage system incorporating a phase change material PCM as the partial cold storage was modeled for air conditioning applications. The system was analyzed from energy, exergy, economic and environmental aspects for re-analysis. Multi-objective optimization of the system was performed and the optimal values of system design parameters were obtained. The exergy efficiency and the total cost rate were considered as objective functions. The result indicate that the electricity consumption of hybrid system was 6.7% and 17.1% lower than that of simple ITES and conventional system respectively. The amount of CO2 emission produced in hybrid system decreased by 7.2% and 17.5% relative to simple ITES and conventional system respectively. So this paper is on experimental basis, and this shows how hybrid system was very useful as in comparison with the IT system and conventional systems. So I would like Danish to continue our paper reviewing presentation.
Thank you, Faisal Hussain. I would like to review paper number 5. Research progress of phase change cold storage material used in cold chain transportation and their different cold storage packaging structures. The research paper presents cold thermal energy that may be the most suitable method to correct the gap between energy demand and supply. In this study, the phase changes cold storage materials used in cold chain logistics are classified in details, and the advantages and disadvantages of each type of phase change cold storage materials are described. Next slide. I would like to review paper number 6. Review and prospects of hydrate cold storage technology, renewable and sustainable energy. Hydrate cold storage technology has been intensively researched in recent years and plays an important role in the macro control of energy. This paper reviews the diversity and variability of hydrate cold storage media and the new hydrate and cold storage system. The diversity is employed by the types of hybrid cold storage media, which include alkane hydrates, freon hydrates, CO2 hydrates, water-soluble organic hydrates, and mixed hydrates. In mixed hydrates, the different components in the mixed media play a different role in the process of hydrate formation. Next slide. I would like to review paper number 7. Effect of an edible coating and cold storage on shelf life and quality of carries. The effect of an edible coating, that is, sample fresh and cold storage on shelf life and quality of carries were studied. Two groups of carries were coated just after the harvest with 10 and 20 gram per liter sample fresh fruit coating, which is composed of sucrose, esters of fatty acids, sodium carboxymethyl cellulose, and monoglycerides of fatty acids. Half of the carries from each of the above groups was stored at ambient temperature and 50% relative humidity. The other half of the carries was stored at cold storage and 95% relative humidity. Each group was analyzed for the following quality parameters: firmness, weight loss, titrable acidity, soluble solid content, sugar content, ascorbic acid content, and external color. It was demonstrated that sample press was effective to reduce the weight loss and increase firmness, ascorbic acid content, titrable acidity, and skin color of the carries during storage time. I would like to invite Amne Sankar to continue the presentation.
Thank you, Danish. I am going to continue the presentation. Review of paper 8. Application and research progress of cold storage technology in cold chain transportation and distribution. This paper reviews the application and research of cold storage technology in cold chain transportation and distribution and points out the research prospects of transportation equipment and problems that need to be solved. The advantages and disadvantages of refrigerant container, refrigerated trucks, and insulation box of cold storage were compared and analyzed. Next. Paper 9. Vapor absorption refrigeration for rural cold storage. This paper attempts to study the power quality challenges in the conventional vapor compression system. With the increases in the utilization, refrigeration and air cooling using vapor compression refrigeration technology, global warming and ozone depletion due to refrigerant have also been increased. There is no way to slow down the growth of this technology, so the focus should be shown on finding an alternative. Various studies have been carried out on the alternate refrigeration system. Next. Paper 10th. Design, installation and performance of 10 TR solar power cold storage in India. A 10 TR solar powered potato cold storage has been installed in a remote village near Baroda. To study its technical feasibility and performance, solar system having 152 selective coated flat plate collector. Nominal area of these coated plated are 304 square meter. Supply hot water at 95 degrees Celsius to the aqua ammonia vapor absorption refrigeration system. The cold storage chamber is designed for storing 75 ton of potatoes at 4 degrees Celsius. A part of chamber is made underground and some collector are placed on its roof, both for reducing the heat gain. Thank you.
Thank you, Amrish Shankar. Now, next slide, please. So these are our references that we collected our information and we reviewed our paper. Next slide, please. Last slide. So thank you this is from our side, and thank you and have a nice day.
Greetings to one all present here. We are here to present a short presentation on the topic trigeneration and use of DCS under the guidance of Professor M.N. Karim. We are students of Mechanical Engineering, third year, and our group number is 26. My name is Abuman Khan.
My name is Sayyid Ali.
I'm Rehan Kumar. Trigeneration. A trigeneration system, also known as combined cooling, heating, and power generation system, is one that generates both electricity and thermal energy from a single fuel source. The prime mover, a heat recovery unit, and an absorption or adsorption chiller make up the trigeneration plant. Since signing the Kyoto Protocol, a lot of nations were looking at the most efficient ways of ensuring energy supply with least possible carbon emissions. Combined cooling, heating, and power generation techniques provide one such solution, as they have almost 80 to 90% energy efficiency with significantly lower greenhouse gas emissions as compared to conventional methods. Vapor compression system. This is the conventional system used in refrigeration and air conditioning. The medium used in vapor compression is a circulating liquid refrigerant which absorbs and removes heat from the place to be cooled before rejecting it elsewhere. A single-stage vapor compression system is shown in the figure. A compressor, a condenser, thermal expansion valve, and an evaporator are typical parts of such a system. Now we'll carry on with the literature review. So the first paper that I reviewed was High-Efficiency Micro-Trigeneration Systems by Kyle Glosenkamp et al. This is a simulation-based research paper. In this work, different types of prime movers are compared on the basis of type and quality of waste heat available from them. A temperature versus cumulative heat transfer graph is plotted for this comparison. The conclusions of prime mover waste heat reveals the promise of microturbines, solid oxide fuel cells, and high temperature proton exchange fuel cells as prime movers in trigeneration. According to the author, separating sensible and latent fluids provide a crucial potential for polygeneration. That is, BCSs can be used for dehumidification duty to raise the evaporating temperature of heat-activated cooling devices. The second paper that I reviewed was Micro-Trigeneration for Energy Sustainability, Technologies, Tools and Trends by Deepesh Sonar et al. This article takes an analytical approach in describing the different techniques of micro-trigeneration available, that is 1 to 15 kilowatts of energy. As concerns about the effects of climate change have grown, a vision of long-term sustainability has emerged, focusing on greenhouse gas reduction. Micro-trigeneration systems' environmental benefits can help reach CO2 emission reductions targets set by the Kyoto Protocol and Agenda 21. Because of the economic, technological, and environmental benefits, small and micro-scale distributed CCLP units have a lot of scope. The third paper that I reviewed was titled A New Hybrid Photovoltaic Thermal and Liquid Desiccant System for Trigeneration and Application by Bosheng-Su et al. In this work, a PVT system is proposed based on various simulations to treat the latent heat load and hence increase the electric chiller performance. An integrated two-stage liquid desiccant cycle powered by heat from a PVT collector is used. Electricity might be saved by producing the same quantity of cooling energy for 50.41% less as compared to traditional vapor compression air conditioning systems at the design point. Due to efficient utilization of solar energy, monthly CO2 emissions are expected to be reduced by 52.9 to 110.95%.
So hi everyone, I reviewed 4 papers and the first one of them is aspects regarding the use of recovered energy for air conditioning. Rajan Kowalt et al. In the paper, the authors analyze the possibility of using the energy recovered from the combustion gases for air cooling. The objective is to evaluate the thermal potential for combustion gases from a cogeneration plant with a 3 megawatt electric power located in Brazil. The authors present a comparative study between the classic cooling system using chiller and mechanical vapor compression and the absorption plants supplied by recovered energy from the cogeneration system, highlighting the advantage of proposed trigeneration system. In the analysis done in this paper, it was discovered that trigeneration system employing ABS powered hot water prepared by heat exchanger have a long payback period than typical VCS system using electric power for residential structure. The other paper that I reviewed is investigation of climatic effect on energy performance of trigeneration in building applications. Pierre Fong et al. A solar trigeneration system for off-grid households based on PVT collectors, photovoltaic modules, and a heat pump whose aim is to provide enough electricity, domestic hot water, heating, and cooling power to meet the typical demand of an off-grid single-family dwelling, is modeled to predict its performance, enable system sizing, and evaluate the impact of different control and management strategies. The energy merit of a trigeneration system was found to be dependent on how frequently waste heat from the prime movers was utilized in the study. It would be difficult to use waste heat to provide space cooling heating to a building if the demand was not consistent and changed due to changing climatic conditions. In order to have a good image of the comparison between trigeneration and traditional supplies, a year-round dynamic system evaluation was carried out. The continental environment with a chilly winter and a hot summer was beneficial to trigeneration in both FESR and PESR. The third paper that I reviewed is solar trigeneration system model for off-grid residential applications. This is simulation-based work. A model of a trigeneration system based on PV modules, PVT collectors, and a HP has been developed and simulated. The design space obtained for the system shows the system is feasible, though costly. And the last paper I reviewed is trigeneration in the food industry. J. Bessos et al. This is an experimental-based work. In this paper, the authors provide examples of absorption refrigeration plants using ammonia as the refrigerant. The absorption refrigeration is combined with cogeneration plants in order to use excess heat for cooling purpose. For example, in a factory for frozen vegetables in Talavera, Spain, a cogeneration plant with 2 gas engines and a total electrical power production of 4 megawatts supplies the thermal energy to drive an absorption refrigerant plant. And another example is in a meat factory in Logroño, Spain, a cogeneration plant with 2 gas engines and a total electrical power production of 9 megawatts supplies the thermal energy to drive an absorption refrigeration plant. Now, Aram will continue.
Thank you, Mohan. So I reviewed 3 of the research papers, and the first of them is trigeneration and alternative for energy saving. The combined generation of thermal energy and electric power is nowadays one of the technologies often used in industrial processes. However, as with all the processes, there are inefficiencies in its operation. Nevertheless, the trigeneration process is an alternative designed to increase the efficiency. Trigeneration plant can achieve up to 50% greater system efficiency than cogeneration plant of the similar size. A trigeneration plant is often described as cogeneration plant that has added absorption chillers, which take the waste and converts this free energy into useful energy in the form of chilled energy. The comparison of fuel consumption is observed between the cogeneration and trigeneration system in relationship to the percentage of humidity. Increasing the humidity in cogeneration system increases the fuel consumption. The decrease in fuel consumption by the use of trigeneration system leads to approximately a 10% saving economically and of energy. And the second paper that I reviewed was biomass fuel transition system in selected buildings. The replacement of all the fossil fuels by renewable energy sources such as biomass and waste is the obvious alternative. If growth in a sustainable manner, the use of biomass, which is considered to produce no net CO2 emissions in its life cycle, and as a replacement for fossil fuels in power generation system, is one of the most attractive applications of reducing CO2 emissions. There are a range of technologies for providing heat and electricity from biomass, but most of these technologies have reduced system efficiency at small scale. Trigeneration as an efficient solution offers simultaneous generation of electrical power, heating, and refrigeration. The trigeneration system used in this research paper contained a downdraft gasifier, which offers a relatively efficient biomass to gaseous fuel conversion and produces a gas with sufficiently low tar. The biomass and biomass waste types selected during the case studies are willow chips, miscanthus, and rice husk. It is economically feasible to use willow chips, miscanthus, and rice husk as a fuel to operate the downdraft gasifier, and the waste that recovered from the system fueled by willow chips is lower than that fueled by miscanthus and rice husk, as the willow fuel requires additional time. And the last research paper that I reviewed was operational strategy and marginal cost in simple trigeneration system. As life quality standard increase, the demand for comfort rises, together with a higher degree of conscience towards environmental issues. Thermoeconomics launches an intensive analysis goes on the design and operation concepts of energy conversion system for the purpose of revealing opportunities of energy and cost savings. In energy system, resources are used up to provide certain qualities to the internal flows until the desired final products are obtained. An appropriate distribution of the minimum variable cost to the final product must consider the nature of optimal operation mode in order to promote rational and efficient energy services production and consumption. This paper dealt with the analysis of the operation of simple trigeneration system only. The cost of satisfying the energy service demand of the consumer center was minimized using an optimal operation mode-based exchange energy flows at market prices and utilize the productive capacity of the installed equipment. Okay, so we concluded through this presentation was that through the literature review, it is clear that BCS that it is the conventional refrigeration system is not the optimal technique when keeping the amount of energy it required in mind. Due to its high energy demand, it also leads to higher carbon emissions. A trigeneration system, on the other hand, is based on vapor absorption refrigeration, which is capable of using wasted excess heat to produce cooling effect. Trigeneration has already found widespread application in food industry, and the current research suggests a household size micro-trigeneration can work as a great energy solution for small communities. Moreover, photovoltaic thermal solutions for trigeneration applications have been showing a lot of promise. And these were the references that were used in our presentation. Okay, so thank you everyone. That was all for today.
Good afternoon. I am Adil Nasir, starting the presentation of Group 27 for the topic of training of personal service sector for Montreal, Portugal, presented by our group members Fahad Ali Khan, Muhammad Kaif, and Mannan Hassan, under the supervision of Professor Mulukar Hawa Karimi. So, Montreal Protocol. The Montreal Protocol on substances that deplete the ozone layer is a landmark multilateral environmental event that regulates the production and consumption of nearly 100 man-made chemicals referred to as ozone-depleting substances or ODS. When these substances are released to the atmosphere, these chemicals damage the stratosphere ozone layer, Earth's protective shield that protects humans and the environment from harmful levels of UV radiation from the sun. It was adopted on 15 September 1987. This protocol is to date the only United Nations treaty ever that has been ratified by every country. This treaty evolves over a period of time in light of new scientific, technical, and economic developments. It continues to be amended and addresses. The meeting parties is a governance body for the treaty, a technical support board, and open-ended working group, both of which meet on an annual basis. The parties are assisted by the Ozone Secretariat. The Multilateral Fund for the Implementation of Montreal Protocol was established in 1991 under Article 10 of the treaty. The fund's objective is to provide financial and technical assistance to developing countries party to Montreal Protocol, whose annual per capita consumption and production of ozone-depleting substance is less than 0.3 kg, to comply with the control measures of the protocol. Kyoto Protocol global warming related to Montreal Protocol ozone depletion over the period of time with various harmful chemical substances or CF or hydrocarbons. So here now let's start with research papers. The research paper one is Introduction to the Special Issues on Ozone Layer Protection in Climate Change, the ordinary experience of building the Montreal Protocol lessons learned and hopes for future climate change efforts. Authors are Kenan, Stephen Anderson, Nancy Leishman, and Brian Garriott. The work here is analytical. So the review of this topic in this paper, the authors have focused on ozone depletion and its regeneration. The release of CO2, methane, nitrous oxide into the atmosphere are also responsible for ozone depletion apart from refrigerants. The authors also highlight various agencies such as UNEP, Scientific Assessment Panel, and UNEP, World Meteorological Organization, and their contribution in saving the ozone. It was evident that industry involved in local development and NGOs are more likely to play a more significant role when the silo walls between stratospheric ozone protection and global warming prevention crumble. Paper 2 says that of the topic, the Montreal Protocol's Multilateral Fund and Sustainable Development. Authors are Ralph Lukin T. and Tamis Grab. Work here is also analytical. Review of the topic is the authors highlighted the need for Montreal Protocol and the project related to it. Also, at the start of the most of the refrigeration projects, international experts often found production lines with outdated equipment and products that were poorly designed with respect to efficiency and energy consumption. For such reason, it is necessary to modify and upgrade equipment for energy application. The authors have also reviewed the refrigerant responsible for ozone depletion. Paper 3. Technical Implications of the 1987 Montreal Protocol for Developing Countries. Authors are R. Leigh, Fag, Benley, R. W. James, and T. G. Karayanis. Work here is also analytical. Review of the topic is this paper describes the role of Montreal Protocol in combating the ozone depletion. The authors highlight the need for such agencies for both developed and developing nations. However, for economic reasons, projects related to Montreal Protocol have been halted. The authors described several issues responsible for slow growth and such agencies in developing nations, which could be catastrophic for the rest of the world. There are chances of multiple holes forming in ozone layer. Now I would like to pass it on to Mohammed Kaif Ali for further topic.
Hello everyone, I am Mohammed Kaif Ali and I am reviewing paper 4, ensuring the climate benefits of the Montreal Protocol, Global Governance Architecture for Cooling Efficiency and Alternative Refrigerants. Author is Won Yong Park, Nihar Shah, Edwin Wine, and the work is experimental. Review. The author stated that in most regions and under most regulatory systems, refrigerant and energy efficiency consideration remain separate despite their benefits. The Montreal Protocol is responsible for phasing out most of the harmful refrigerants and ODS, which is chlorofluorocarbon (CFC), and halogens used respectively in older refrigeration and firefighting system, and portable equipment ODS were also used as blowing agent in some insulation forms. Paper 4. Knowledge Management in Development Project, a case study of Hydecor project in India. Author Surinder Batra, and the work is experimental. Review. The paper examines a development project called Human and Institutional Development in Ecological Refrigerant HIDECOR in India. The author worked later as the consultant for certain specified project activities during main phase of the project 2001 to 2004. The author also described the concept of knowledge management specifically for development project to be successful. Paper 6. Present and future trend in atmospheric burden of ozone depleting halogens. Author is J. H. Butler, J. W. Elkins, T. M. Thompson, J. W. Clark. Work is experimental. The author shed lights on consequence of Montreal Protocol, and as a result, concentration of chemical OS on decline since 1994. The paper is experimental and work has been done on concentration of different chemicals in the lower atmosphere. The data also indicate that the effective equivalent chlorine concentration is also in decline since 1995. The paper also reviews the effect of different halogens on the ozone layer. The author also stated that any new production and use of these CFCs in recent year would also contribute in continued emissions. It has been suggested that CCl4 emission are closely tied to CFC production. Paper 7. Global Environment Facility investment in the phase out of ozone depleting substances. Author Robert K. Dixon. Work is also experimental. Review. The author explains how to stratospheric ozone depletion threatens human health and global environment. One table indicates the ozone depleting potential of different compounds and their uses. A brief description of Montreal Protocol implementation and its achievements was mentioned. The author also explained the economics and phasing out ozone depleting substances (ODS) reduction and measured according to the phase out timetable and targets to the Montreal Protocol and embedded and adjustment. Now I have over the presentation to Fahad Ali Khan to continue the presentation. Thank you.
Thank you, Kev, for having me. And I'm presenting paper number 8. It's about the hydrocarbons as a refrigerant. It was published on 14th of August 2017. Work Analytical Review. Air conditions and refrigerants have some full circle since the Industrial Revolution. The author explains how important it is to understand the consequences of releasing refrigerants. With some emergence of new technologies, RECs can be used with hydrocarbons. This can be done by the redesigning the equipments and the components for the use in ACs and RACs. The author explains how the concept is already being used in Malaysia with the R410A, with introduced as a replacement for HCFC 22. Paper number 9. Monitoring the success of implementation of the Montreal Protocol in India with satellite measurements. Published on August 2009. Author was Nandita D. Ganguly and K. N. Iyer. It is a work analytical review. So the paper described the man-made chlorofluorocarbon CFCs could play a major role in the destruction of the stratospheric ozone worm of the long-term global ozone depletion due to the catalytic reaction of stratosphere involving the chemical released in anthropogenic activities if it means unchecked. Or paper number 10, implications of Montreal Protocol with the particular reference to India and other developing countries. Author K. Chatterjee, published on August 1995. Review. It is a work experimental review. The paper mainly explains the challenges that are faced while implementation of Montreal Protocol in developing nations. The increasing levels of chlorine and in the stratosphere due to the industrial production of emission of chlorofluorocarbons and others. Halocarbons are the main cause of the ozone layer over Antarctica. According to the recent scientific evidence, chlorine and the concentration are expected to rise over the Antarctica. Developing countries with a per capita consumption of CFCs of less than 0.3 kilograms were allowed to delay the compliance of 10 years as per the Montreal Protocol. The paper also covers the environmental implications of Montreal Protocol. And next slide, please. Here are the references which we take from. They are the last was Wikipedia. Thank you so much, everyone. Have a great day.
बोल दियो. Hello, good morning everyone. Welcome you all. My name is Mohammad Subhan. I am a student pursuing BTech Mechanical Engineering from this Jamia Millia Islamia. My topic is method of cleaning condenser water system presented by MD Subhan. Now, what is the condenser water system? Condenser water system are used to remove that heat energy from the building and reject to it the atmosphere. Now, next slide. How does the condenser water system work? You will see to learn the process in which the system works. First, you must understand the refrigeration cycle. The most common method of the rejecting heat through cooling tower is located outside the building. Now, let me explain component of the system. Cooling tower, condenser water pump, chiller. Now, my first review research paper, development of system for wall cleaning of condenser and experience of their operation. Now, author J.I. Ifomokeni, publication 2002, simultaneous base. Now, let me explain the development of method of cleaning system turbine condenser tube with the help of porous rubber ball. Technology company, Germany by Russian specialist is presented. My second research paper by following and its control with the particular reference to condenser cooling circuit power plant. Now, author KVK Nair, publication 99, type experimental work. My following has been major problem to the ship offshore platform, hernia intact data buoyance, and to the almost all Marine technological venture. With the emerge of the multiple megawatt power plant during the last 3 decades, more and more nuclear and the thermal power situation are turning to the safe mode where cooling water needed. My second research paper, the practical application and innovation of cleaning technological of condenser. Author Andy Howell, publication October 27, 2008. Types analytical work. Maintaining cleaning condenser tube of the vital importance for reliable of efficient power generation. To more major problem result from the substance on the interior of the tube surface. I lost the heat transfer and under the deposit corrosion. Now, conclusion. The efficiency analysis proves that the chemical and non-chemical treatment system are capable in maintaining operating parameters such as the pH, water alkalinity, iron content, chloride content, TDS, water electrical conductivity, and water hardness by complying the industrial standards such as the GRGL 0 1994. Thank you, everyone.